experience, my working, my field practices, which I have been doing all along my service. I hope that will be useful to you. My firm belief is this, that your knowledge or your technical tools, technology should be simple, should be user friendly, and should be as such that without much knowledge, without much effort, people are able to use it. And if it is going to change their way of farming, if it is going to change their way of applying fertilizers, as it is costly input, it will be a wonderful experience for him. It will be a lifelong lesson for him. It will be an economic price for him. Yeah, struggling with your friends, knowing that will help you to write it. All along the globe, you are seeing the blah, the human drive for decline by that. I will be telling you my slides in 3-pronged way. No better than last 2 years, we have experienced what is called testing. And also I have to know what is the status of fertility, architecture, the status of nutrients, the contemporary condition of the soil, other than testing. You see, last 2 years we all have submitted ourselves to testing. Testing is must. Till we test ourselves, we will not be knowing what is the situation, what is the gravity of the situation. So, for several years, we have done a lot of laboratory analysis, a lot of laboratory manuals, preparations, and 16 states of India I have worked. So I have the database with me regarding what is the scenario and how we have been using the soil and how it leads to different kinds of abuses. It leads to different kinds of situations. See, soil, how we define it, soil of infinite lives, is in crisis today. Why? Much of our interventions which we have done is not based on scientific principles and practices. And even if it is based upon certain recommendations, the impact is before us. Soils are polluted. If you see the map of India, and the plains of India, decline of soil organic carbon, what does it indicate? When we came to know that from carbon content in the soil, which is varying from, if you go towards the northeastern hill region of this India, the geographic situation of this northeastern hill region of India, where the carbon is more than 2%, SAR, what we call it. And you come to IGP plains of India. This is the IGP plains of India in the map of India. You see Indo-Gangetic plains, maximum civilization, the maximum population density you will find in India is along the riverine alluvium, along the river side only. So this IGP plains of India hosts the maximum population density across this world, where the decline is very severe. So severe it is that policymakers, the practitioners, they had to raise this concern about soil health issue. How it happened? They're doing it. See, in the mindless effort of grow more, 1966, this campaign happened, you might be knowing. During that period, India attained its green revolution. So during that time, there was a campaign called Grow More campaign, where in which the first time we saw the impact of fertilizer application in the soil. We had to grow more at that time. You know the crisis of year 46 scheme of the USA. So during that time, this was must. But afterwards of 20 years, you have seen that what it has led to the situation is now Punjab soils. You must be knowing also that in Punjab soils, most of the areas are highly polluted. The IGB planes also are highly polluted. And don't mind, some of the paddy also nowadays are called as poisonous paddy. Have you seen the residues level of pesticide residue level of those paddy, the grain? Have you seen ever what is the water quality in those areas? Number of cancer cases increasing. I am not alarming you, I'm not alarming the situation, but with one report of World Health Organization, if you see and if you remember, very alarming situation has been raised for India. Already, some of the regions you will see 10% of the population is affected with cancer cases. Where it is happening? Why it is happening? It is due to your soil. Because we are integrated with our soils, our water, our air, our grains. This is a cyclic pattern in which we cannot keep aside ourselves. And this year has come. Why we are telling you, I have brought these pictures to you, is that this is the way we use the soils. And this is what is defined our soil practices and land use practices. Now, this is one such land pattern I am going to show you. Perfectly, you will come to know how we calculate, how we know soil health. The integration of the architecture of the soil, that is the physical parameters, physical indicators of the soil. Now, the physico-chemical properties of the soil, such as your soil reaction, such as your soil pH, such as your cation exchange capacity, and such as some other chemical parameters, or call it the chemical indicator of the soil. That means chemical health of the soil. Then what are your nutrient status? You already know, for plants, human beings need 18 elements, but for plants, only 16 essential nutrients are required as per Agronomy South 1939. So, with that criteria of essentiality, what is the status of those 16 essential nutrients in the soil? Called as soil fertility. The inherent capacity of the soil to supply all the necessary essential elements is known as soil fertility. Am I correct? So, then what is your biological diversity happening inside the soil system? What are your amoeba? How much is the population of your algae, fungi, and what are your biological parameters existing in the soil? What is your soil respiring? Whether your soil is respiring or not. If the soil is respiring, the pulse rate, the soil respiration rate, calculated, integrated, called as soil health. So integration of the physical, chemical, fertility, and biological parameters is known as soil health. And when I told you the decline is happening, there are ways, there are methods by which we know. Such as one such approach I tell you is STCR. Some of the soil science people, some of the soil scientists might be knowing also what is called soil test crop response. This is one such skill set which will enable us to know whether soil is responding or not responding. How much it is responding. This way we come to know the power, the capacity of the soil. Now, in this picture, I wanted brought this picture to tell you that you are seeing a physiographic situation in which you will find a lowland, in which you will find plateaued land, hilly tract, undulating tract, terrace system. You name a land use system, you will find in this kind of land use system. You see, this is my actually the Asher North Division Research Complex, my farm, experimental farm, when I was working there at that time. So this is a very beautiful depiction of your different land use system. This will give you a picture of in one piece of land how land use is changing, how impact of land use is on soil health. Soil health of this upper status will be far different with those of terraces, will far different with those of lowland tracts. So lowland, that is called zone 1, zone 2, zone 3, tar 1, tar 2, tar 3, and then compare it with these slopes, compare it with these hilly tracts, compare it with this terrace land, all will be different. Here only you can come to know what is the status of soil health. And now, farmers have been doing farming here for generations in this area. They are adopting one system of cultivation. You might be knowing some other people from Meghalaya. or if you have heard this kind of farming system, one system of farming, it is practiced only in Meghalaya. This is a question being asked in the examination also. Remember that. One system is practiced in Diana land was the last year. Diana land is practiced in which kind of land system. So this one system of farming is only present in your Meghalaya. But in Mizoram and elsewhere you will find home system of farming. Why that problem I will tell you later. Why they go for farming. So this was the land use system I wanted to show you to make you aware that our land use is different. Our land use pattern is different. Our land use fertility also will be different. And as a result, soil health also will be different. Now, this is not as simple as what I have told you. And this picture is not giving you as such the chemistry of the land, the chemistry of the soil, making it very easy. No, it is not as such easy. How to know more about the inherent problems? Here is what our decision support system are. Different advancement in engineering technologies is helping us to gauge the problem, to understand the problem. One such problem which I was telling you and which will lead to impair in the soil health status is that's why we need a DSS. A DSS is a programming device, programming software. I am not an engineer, I'm a soil chemist, but so I have interest in their activities, what engineering people are doing, and I want to know also what our engineers are doing. Our engineers are doing very good job. So why DSS? The DSS is required. It will help us. It will enable us checking our data, interpreting it, and giving us the answers of our problems, which we may not be able to know why we are doing farming. And as a result, as a mindless practices, our health will be declining, our health will not be improving. So that's why we need a kind of system, a kind of health, which will aid in decision, and due to that decision, we will change our fertility status, we will maintain our soil health status. That's why these are digital approaches, these are engineering approaches, these are mathematical approaches, these are computer devices, these are Internet of the things, IoT of the things, because we will be seeing how it is aiding us, how it is helping us to know, to decide how to manage soil. So my topic was not a very devious kind of topic, that digital soil. Now we are not going to manage digital, we will be managing soil with anything you want to? Oh, no problem. My voice is okay. What will not do? I have a habit of roaming on. Acha, okay. Okay. Okay, sorry. I was not, I thought it's like a class. I will be roaming all around the class. No problem, I'm taking care of that. So, what I was telling you is this, that how certain small devices, although they are costlier. One more thing I want to tell you, in the attraction of using engineering devices, in the attraction of using digital devices, we should not make our farming very costlier, because there is a strong chance, a strong likelihood that while we using this very fascinating kind of devices, we will again make our farming costlier. And here is a very I am flagging this issue for all of you, that in the want of attraction, the want of having fascinating kind of devices, we should not raise the cost of cultivation to our farmers. That will be very dangerous attitude. So whatever we do, we must keep in mind that cost should not escalate. What is right the cost of cultivation? See, technology should enable us. Technology should make us solve the problem, but it should not solve the problem by which we will be dying by having no money at all. MRI is fine, X-ray is fine, but how many people can do MRI and X-ray? That's what I'm telling you, that we should also keep in mind the cost should not escalate. Now, here I am showing you a spade meter. The cost is very higher, but it aids immediately in the field. Instead, see, why I am telling you that two devices are there. Now, we are on the verge of making digital leaf color chart. That will be first in India. This also, my institute, Indian Institute of Life Research, we had brought out this leaf color chart, although leaf color chart is not ours. It was first built by Fukuoka in Japan, then subsequently in Erie, then subsequently to PAU, then subsequently in America, then subsequently we have also made it. All whoever is using, even one company is there, one startup is there, you might be the nitrogen parameters, that they are also making this nitrogen leaf color chart. Why I am telling you leaf color chart is there are same decision being brought by two different kinds of interventions. One is your leaf color chart. Keep it in your pocket, go to field, go around your plot, as many leaves you just compare it, match it, behind the chart is your answer line. Means you have how much you get to apply, you must how much nutrient to apply, depending upon which panel it is falling in. As many as you can put. Now this is requiring a only fine-tune printout, final prints of this leaf color chart. Very, very low cost. Absolutely no cost from our institute. We give it free also to farmers. But here is a device, this speedometer. It will give you a digital reading. Some of the students might have used also this calorimeter, this is speedometer, isn't it? For your practical classes. So this is a device which is costing around 2.5 lakh minimum. And here is your leaf color chart. Now same is it will not give you a digital reading. It is bringing to you a panel-based kind of color visual identification of nitrogen, and it will give you what is your leaf nutrient status, what is your nitrogen status in the leaf, and what is your nitrogen in the leaf is reflectance of your what is happening inside the soil system. This is what I was telling you that it will lead to. Now, my friends, here I would like to tell you there was a problem. If you suppose that in Mizoram and northeastern region also people are aware of it, that citrus decline happened. There also might be knowing some citrus plant might be there. In Maharashtra, citrus belt is there. So there was a citrus decline. At that time, Honorable President Dr. APJ Abdul Kalam Sahab, me also, I was the part of that expert committee member which had visited. Now, when we visited, we saw very small reasons plants died. This is citrus plant was the lifeline for our poor farmers of Mizoram. So when I came back, submitted the report, all the report, blah 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 blah, whatever report we have seen, that only we will submitted. But it haunted my mind. Why our poor farmers, they are not having a single 10 rupees also by selling one orange. So then I decided I will make two technologies. I made one field level technology immediately with their own technology that I am not showing you because this is a digital soil health management lecture. So here I am showing you visual based one diagnostics I made. And this was based by, you might be knowing Dr. K.L. Chadha Sahab. K.L. Chadha Sahab gave me best prize for this during 2007 your International Horticulture Congress. So this was a visual web page I made. In that, what I did is that I simulated how a leaf will look like once it is infected with a pest, particular kind of mite, particular kind of the worm, or particular kind of any other insect pest, or if how it looks like once it is infested with low nutrient deficiency or CNC, critical nutrient concentration is falling below the level, then it will show you. Now you click mouse click, do it mouse clicking. You see, just you mouse click it here, it will take you to very intermittent process, and you mouse click it here, fruit drop. How fruit drop? Entire, it will better show you in this picture. Me and Vishkarma, this was developed by me and Vishkarma. Earlier on, I had myself developed. So in this, you will see we have a software also, citrus decline software we developed at that time. That also was very popular, very cheaply. It gave people good knowledge about why it is happening, why are citrus trees are declining, and remedies are available. So this was what I was telling you. A computer device, a small knowledge, brought it into a visual identification kind of image, will give you immense knowledge to identify the problem and to solve the problem. Got it? And you guide the problem. Otherwise, it is very difficult. You have to now, as advancement is happening, you are seeing you hear to all our engineers only. It's very good. I heard IIT. I met also IIT people have come, and all good engineers are also here. So they will be showing you all good technologies. What I have been using with their internet of the things is that I am recently mentoring one project called Krishi Rasta, Rapid Automated Rasta, RAS, Rapid Automated Soil Testing and Agronomic Advisory System. We in India giving advisory services very poor actually. Our advisory services are not at all reaching to the farmers first. Our advisory services are very big also, sometimes very big. Nobody is bothered about those agro advisory services. Sometimes it is too technical to know. Now we are devising a automated soil testing rapid agro advisory services device. I will show you. I will tell you. And this is there is a startup now we have developed. Not me. Companies have come. Engineers like boys. Oh, your engineers are there. They have come up with one startup, and now it's very good, very big agri startup in India. I am the mentor for that startup, and I have developed. This person is me only. This is I have become a little muta. So that time you see small hand devices was GPS global positioning system devices. So that why I was telling you, I am reminding you. At that time also we were using some electronic devices for our sampling purposes. How you do sampling? Simply people are collecting and throwing in your laboratory is not the way to do soil sampling. A better way is to go for GPS-based sampling, GPS-based surveying and sampling. Like this we did for Mizoram. Earlier, before this, there was not a single information. If you find for Mizoram state and northeastern region, now we will have a lot of information. We have hosted also in our other databases in our this decision support system. We developed a lot of JS-based maps. IT movement people were there. Their gram plus and their software is there. So that software only we have developed some of the maps. This is the one map I will show you. You see this map for my farm. My institute name was DRR, Directorate of Rice Research. Now the name is Indian Institute of Rice Research. They're changing the names only in India, everywhere. So this map is my our farm, ICR farm, here farm only. With that gram C++ software, very small device, 5,000 may be purchasing. But now you cannot buy in 5,000 those very costly software now. It is very difficult to find out. So with that software, we made it this information support system. My friends, you might be knowing, Honorable Swaminathan Sahab is having Gramin Gyan Abhiyan movement. Through MS Swaminathan Foundation, one is in the headquarters is in Chennai and the other is in Koraput district of Odisha. So some of you might be knowing also. So I have been visiting those places. So at that time, in the Gramin Gyan Abhiyan movement 2008, I was invited for this model which I had developed, e-village. 2008 when we had developed this and I had presented to Honorable MS Swaminathan Sahab. So what we had done is that the land use system picture which I had shown to you, each land we digitized it and their properties. Now mouse click it will be available. And we made a complete village picture electronically and we presented in web-based system. That we call it. At that time, it was inaugurated by Honorable Chief Minister of Meghalaya. So this was the soil test report also, but it was very crude method at that time which we adopted. Now the better ones we have made it. This was yesterday. My friend Viskarma might have presented to you. This was one of the software which me and Viskarma together developed for Jhum kind of cultivation system. No knowledge at all which is existing for Jhum cultivation. Only very mere some of the information you will find in some textbook or in some technical bulletins or in some research or reference papers or at the most publications from Northeastern Hillism. But in this software, inch, every knowledge of your Jhum, what is called Jhum cultivation, how it is practiced, how this software will be found on mouse click. Likewise, we have developed for irrigation scheduling. Very important, I tell you, how to schedule. This is only leading to now automated kind of devices which is now coming up, and you are seeing the app-based irrigation scheduling and irrigation timing management, how it is done. Before that, this software we had developed. So this software actually, based on all your parameters, it will calculate at what time, how much quantity has to do irrigation scheduling. One such problem which we had identified, besides that problem which our farmers had shown to, was the soil acidity. Now the level of acidity will define the level of acidity in the soil solution will define your yield. My friends, you might be knowing yield penalty is very common. Very common yield penalty in acidic soils. And soil-related infertility syndrome is widespread in acidic region. Now, in acidic region, how will you come to know? Bookish knowledge you might be knowing 49 million hectare and then 3 million hectare. Around you say so roughly, your 1/3 of your Indian land is subjected to one kind or some other kind of soil acidity. Now, this soil acidity you cannot cure easily. You cannot cure easily. It is an inherent problem of the soil and forms. Earlier morning, I had shown to soil science students how simply you can calculate. How can you imagine? How can you know soil pH? Very simple device. Here I will not show to you. But in this lime model, which was the India's first lime model, it is India's first lime model. What we did is that just you place or put what is the value of pH, what is your soil pH, and that's all over. Click it. It will calculate mathematically your lime requirement. Friends, you might be knowing without lime, the pH of the soil will not come up. Come up means suppose that it is 4, 4.5 or 5, it has to come near 6.5 to 7.5, near neutrality. Unless until it reaches near neutrality, it will not fetch you the optimum genetic potential of the crop. That means if 5 ton yield you have to get, you will not achieve 5 ton yield per hectare yield productivity. You will have yield penalty. How much you will get? You may get 2.5, you may get 3. This is what we get our rice productivity in such acidic soils, such acidic region. Why? Decline in your soil properties. That's why I told you acidity related infertility syndrome in the soil is widespread. And how to know? Nearly 1/3 area, geographical area of the India is affected with 1 or 2 kind of soil acidity or acidity severance or severity. Now, to solve this problem, to check from farming, repeatedly farming in those areas, we need lime. That's why it's very, very important. My friends, we are fortunate that this lime model is being used by Northeastern region and donor ministry, which you know, the mini planning commission for Northeastern region. So this was very important. Now you see another DSS support system. Very simple device we had made at that time. Very simple software we had made is that there are different types of cropping system available and prevalent. You will be shocked to know, very rarely we know, in one piece of land, you have not imagined more than 3, 4, 5 crops in a year. Suppose that if I ask you, in a season, in a Kharif season, in a Rabi season, or in one particular period of time, I ask you that my land use system is having 35 such crops. Can you imagine? This is the wonder of that tool. Now, if you have 35, more than 30 or 35 such crops in one piece of land, in one period of time, or call it one Kharif season or one Rabi season, how to maintain the nutrient requirement? How to maintain the soil health? Here, who will advise you? This DSS will go and you go and click it. Simple mouse click with just 2 to 3 questions. It will ask you, what is your soil property data? Do you have NPK status? If you have NPK status, just you put it and select your crop. You see, it will bring your immediately a economical kind of recommendation system. Means based on inherent soil fertility status. Not now. Now you have not added any fertilizer or any manure or anything else. But inherent capacity of the soil, which I was talking to in the beginning, that what is the soil fertility? The inherent properties of the soil is how much proportion of the soil inside the soil, how much proportion of nutrients from the soil is available to the crop. Now, based on that, it will economize your nutrient recommendation system. See, it's a very complicated knowledge, but made very simple. This is where I am telling you, this software will help you in calculating the nutrient requirement. And nutrient requirement is what is our entire fertilizer industry is based on. 1 lakh crore simply we give to these companies in India. As you know, government of India is giving subsidy only. Can you imagine the 1 lakh, how much crore rupees going in this sector alone? And here your helping decision support system will save a lot of fertilizer, lot of subsidy money, lot of subsidized amount which government can use it in elsewhere places or other social sector schemes also. Now another very simple device we had made at that time, very simple picturesque kind of one web page we had made is that touch screen based fertilizer recommendation, which you will not find elsewhere also. You see in Meghalaya, there are only 8, you see here, this is a map of Meghalaya. Okay. Now, it is asking you, since I was principal investigator for 3 crops, at that time I had experimented with only these 3 crops. What we did is that I imagined a person can keep a map in his pocket. Now, click, suppose that. There only it will reflect. I will click and it will, just to click your district. I belong to Riboy district. Okay, Riboy everything. Simply it will give you how much India, how much things are. This is one such simplifying kind of technology. Complicated database is there, but it will ask you to go start internet, have power, have internet, everything. But in this, just click it and keep a printout, put in your name. Over. And you cannot challenge. You don't think that it is a changeable one. It is STCR based, project based, database based, pedo transfer function equation based recommendation system. That means it is thoroughly validated one. It's not a mere sake that I am recommending to you. I told you it's STCR based, validated based. So this such knowledge will help our farmers to know more. Now, when we had come, you know, rice is 40% of your cropping in India is rice. If you see the total cultivated land of 45 million hectares, this is rice field. Rice is the area is 45 million hectares. What is rice productivity? Right now, this year, from second advance is 128 million tons. It's rocking at rice in India. I belong to that institute which monitors entire rice ecologies in India. We are the body which releases your rice varieties. Any rice variety which has to be released, it has to come to us for testing, our institute. And we only test it all across different rice ecologies of India and then recommend to government of state government or government of India. Generally, we will recommend to government of India. That is called CBRC. You might be knowing some of the people might be knowing who are working in the ARGL or Agri. So, in this, very important, rice consumes your 40% of your entire fertilizer. My dear friends, you might be knowing 40% is a big amount. Now, how to save costly fertilizer? Now, here we had applied that. This is what I had told you in the morning session. Also, I had told you that there was a rice RKMP project. It was a very big project, and at that time, sorry, that time, Honorable Prime Minister Dr. Manmohan Singh Sahab had released that was world's first serial-based portal, Rice Knowledge Management Portal, RKMP portal. So at that time we had developed this, and this was 35 top varieties. We have released more than 1,500 varieties till date from our institute of rices. So in that I selected 35 top varieties of rice, and then what are the nutrient requirement of those top 35 varieties? I was known. We at our institute, we know what are the nutrient requirement of the rice varieties. This knowledge we use it for making this DSS, Decision Support System, functional. Very easy. You will see also how it will work. Now, in this DSS, it will again ask you what is your soil test values, because you know until you give soil test values, you will not be knowing how properly to manage our fertilizer and to maintain soil. Correct? Now, in this, it is not going to ask you if you provide your exact status of carbon, or otherwise it will ask you the period. If you are not giving the period, it will calculate for rice is grown in 4 to 6 months period. At the most, the longest variety also will be harvested after 160 days. This is the maximum the rice will be there in the field. That is the sort of variety. It takes longer compared to other varieties. So at the most it will be 160 days. Now, 160 days period, it will calculate okay, organic carbon, organic matter, it will give you 15 kilogram matter per hectare. Now, in this what is happening is, you will see we have devised one indexing system. That is called, here you see, Nai Pi Kai, NAI, Nai, PAI, Pi, KI, Kai, nitrogen availability indices, phosphorus, potassium. What it does is that how much it has mathematically taken away from your recommendation system, from your requirement. Suppose that my requirement was 120, 80, 60. This is a very famous NPK recommendation system across India. It is recommended, isn't it? Any soil scientist will tell you 120, 80, 60 is a very simple, the simplest and the widespread recommendation system being followed in India. Now, it is without any logic. We are recommending 120, 80, 60. But if you see the crop nutrient requirement, a motor person will have different crop nutrient requirement, a patla person will have different nutrient requirement. So, are having different fooding requirement. Na? Likewise, our crops also, varieties also will be having different requirement. No? We must know what is our exact requirement. Based on that, provided the soil test values, now it has calculated your 9, 5, 9, and when it was 160, 80, 60, it has come down to your, you see, it is 135, it is 63, it is 47. See, it has reduced. Now, this much it has brought saving to your farmer. It is more than 30% saving. 30% saving is, generally I tell you, in Kharif season or in a Rabi season, any farmer in India, anywhere nowadays, he is spending around 10,000 rupees money in urea, DAP, or some sort of different types of sprays, or some sort of humic acid, fulvic acid. Total cost, if you see it, for a farmer for 1 hectare area, he is incurring a cost of 10,000 rupees. Now, 3,000 saving is his income only. This is one such model will make you economize your doses. Now, my friends, at that time, there was very halagulla at that time of giving soil health card. Now, also you might have seen very claims are made 13 crore, 12 crore. I will not go much beyond that. I'm also government servant. So, a lot of halagulla is there. Thousands and thousands of crores have gone. Do you know that? Due to that, it pinched me. I felt very bad. Why we are spending thousands of rupees of no use? My friend is very excited with that. There was a 7, 8 years back, I had developed this one. Online e-soil health card generation system. Very popular at that time in RKMP portal. It was developed a new. Now, here in this model, very simplest kind of interpretation system we have done. What is that? See, doctor caused your diabetes ranges, sugar ranges, correct? He understood your respiration rate, these, that, last one. Now he is telling you 135, 120, 260. What is the meaning of that? What is the meaning of this? Similarly, when we do soil testing, we are recommending 150, 250, 350. What is the meaning of this NPK status? Now, in this model, the moment you put the value, it will work like traffic light. It will blink green, red, or you see that yellow is brown. I call it yellow for easier understanding. How? The traffic light nobody will forget in his life, and everybody knows it. What is the meaning of traffic light? The red light is a chala danger area. Means your soils are in dangerous condition. Means your soil is low in nitrogen status. Your yellow color is medium in status, and green color is very high, very good. Soil is very good. Soil health is very good. Now, if you integrate entire parameters, it is very difficult for even researcher also to know what is your soil health index, what is your soil quality index. Now, the moment we know entire aspect, entire parameters and their interpretation system, we are done with. Take a printout, know your soil quality index. Even in your bad card, index is not coming in the other cards which is given to the farmer. Here you can simply click it, it will give you your soil health status is average, or your soil health status is very fine, very good, excellent, like that kind of index. This is a very popular soil health card index system. It has been maximum, it has been downloaded from our RKMP website. In that website, you will find this. And not only for that, people are going actually to this site to develop their own indexing system. And mind it, how many times you need, how many times you are changing your land, your system, how many crops you are taking, n number of crops you take, n number of times you change the data, n number of index interpretation system, and n number of cards you can generate, and n number of soil health index you will be generating, which is not possible physically. Or like this, actually I told you very popular it had become. It has placed us good name and fame. People are using it, chanting our names. We are also very happy, and it is serving the purpose. So it is in our campaign. This was what I was telling you. So India's first, not only India's first, it was world's first serial-based portal. That was our campaign. I was a co-principal investigator in this. There are any further model is there. I will not go in detail. See, this is also one Mitra app device. Now, what is happening is that now people are telling, fine, web-based system, fine, other devices. I want in my mobile only. Now they want in mobile. So those knowledge now we are transferring it in slowly in app-based systems. One of my friends, Dr. K.C. Sibalan from Tamil Nadu, me and he is working together. We have developed this device, Mitra device, Mitra app-based device for your fertilizer recommendation. Now, since right now it will be only in 2 languages, is in Tamil and in English. I am thinking of making immediately in Hindi, but because it is also a language. And now, in your hydroponic system, if you see how they are managing soil and the soil health and crop health, QR based recommendation system is being generated. Nobody is applying here. You see in this photo. No farmer is applying or Naxxam sprayer is putting or blanket broadcasting. No. It's all QR based system. All mathematical. These are all devices. It is being practiced in China. Here also in India, it has come. If you have heard about Urban Kisan in Hyderabad, they are following this kind of system. In Urban Kisan, the owner is my friend. Three of us. One owner is my friend. I am not the actual mentor, but we are also giving him good advices. So they have followed this method. In this, what do they do? Nobody, no human intervention is met. An entire nutrient requirement is fed by all QR based system. I am also not knowing much because all engineering, I told you I am not an engineering background. And there also in our field we have installed this and in farmers field also, which I was telling you, the irrigation scheduling. This also app based, it has come now. I have recently been associated with one nano urea IFCO application through Chrome. I will not go much. You are already having good number of people. आपके नाहब के लोग बहुत अच्छे लोगों को लाए हैं. मैंने देखा है बहुत बड़े लोग हैं. वो बहुत बढ़िया आपको बताएंगे. सब कुछ उनसे पूछेगा ढूंढ क्या है. Last portion of my lecture is this only. That sorry, little water I will take. So last part of my lecture is testing. Here I have my own experience. Right now also I'm working. I will show you. First I will show you the other inventions, sensor based, very rapidly changing the way we do testing. And one in which I am associated and we have developed, very important that is sea soil testing. This is also a multi-billion-dollar industry. And in India, you might know, any soil scientist will tell you also. But how much government of India money has gone in establishing a soil testing laboratory in the name of laboratory, in the name of testing, multi-billion, अरबों रुपया चला गया भारत सरकार का. टेस्ट वही का वही है. अभी भी इसका लैब तो बहुत अच्छा है. Very good. I am first time coming. I saw your lab. Very good lab. The functional laboratory is what gives us satisfaction. But rarely you will find across India the functional laboratory. I will not go in detail of those kind of things. Maybe it is none of them beyond this lecture. So this is what is this one device I will tell you, soil cares. I was exposed to this technology when I was working in a UNFO for them an ITPS member. At that time, this soil care people from Netherlands, they have developed one sensor-based detection technology. Right now, IIT people also you can ask them. IIT Kanpur has developed. I wanted to know how they are doing it because their parameters are different. But anyway, so this is what actually at that time they are estimating pH, CC, N, P, K, and they are estimating carbon also. These many parameters they will test it. Dry soil sample they need, and they put like this, and this sensor measures it. Like this sterility also same. Reflectance spectroscopy is the key thing they are adopting, and based on those parameters, they are indirectly measuring it. But I tell you, I should not say, I'm not discouraging. The people are engineers who are very good people. Go ahead. But you be associated with some great chemistry people. If you are coming to measure soil, you associate with chemistry people. The analysis in chemistry testing is wet chemistry based. So if you are developing sensor based, fine, I am not denying you. Go ahead, develop it. But you validate those things with your chemistry based interventions also. See what is your parameter tested, what is the value you have got, and how much it is validating or nearing with what Praveen Vedya has got in his laboratory. Suddenly you have developed it Suddenly you jump in the market, formed a startup, started selling. You are bound to fail. Is what is my experience till date. 20 years of experience, working experience in my ICS system, along with UNFAO system experiences working. I can tell you, you need a validation in soil testing from wet chemistry base. That's why I'm telling you. A wet chemistry person, an analyst, he knows analyzed it through your sensor one time and immediately you are not doing it, then go. Then you will have problem. This is again sense graph, that same device, same practice they are following it. And this is now coming in India also like this. They are same crop X, optics on farm. This is one such device which I tell you mentored it, thoroughly mentored it. I am their developer. But the startup is research where in which all the scientists who are recruited, they are being first trained there. So we have their Agri Udan, a business incubation center. There actually all the agri startup people are coming and getting their ideas incubated. This is one such where I was involved. I was expert, I was mentor. In this, what actually happening is that a cloud-based computing system they have adopted. Very simple. Initially, they also came, you see, jumbo jet structure they brought. When they had come in now, they had come with a very jumbo jet structure. So at that time, I had mentored them, no, this jumbo jet structure has to be brought into simpler devices. So I told them to 4 or 5 devices, which it was looking like, we brought into single device. And you integrated it with your API and in mobile app system. So I had told them at that time, then they developed like this. And this is there now only one device. You see this one. This one. This one is there only one device. You see. Now this what their work is. One app will be there. You see, Rasta they call it. Rasta, I had told you, is a rapid automated soil testing and agronomy advisory. This is very important because we are using right now 43 crops, recommending agronomy advisory services in 43 crops based on your soil test value immediately within 20 minutes in your mobile phone. I will show you. Now this is the way layout I told you how it works through app. Now this is the chart you are seeing. Actually, we are still evolving, but in this actually I have told them you bring everything, your interpretation system, your value tested, your rating, fertility rating, and your nutrient recommendation, and this will automatically come in your card form in your mobile immediately. The moment machine has finished the testing, immediately you are getting your card generated in your mobile phone. And this is right now actually available for 43 crops. You can see in this some issues were there. Sometimes micronutrient parameter will not behave properly. So there will be in likewise in the stock market also you see how in lower circuit, upper circuit input ladder. I had to put upper circuit. It's still evolving, but now this Krishi Rasta has become very famous in India. Very famous. It is now top emerging agri startup in India. Sold, and now IIT Mumbai also is a partner in this. What is called equity shareholder like that. And I am Kojicode and NABARD. NABARD is here. So now it has become very big. This startup, and some started by some 2-3 engineers only. Now this is our sugarcane picking institute, one ICR institute, one institute. They have developed this again. You see, green light, green yellow light kind of moisture indicator. Again sensor based. We will put inside it, and immediately it will flip one color. That means it will show you whether the moisture is there or not, or what is the availability of the soil. My friend, why it is important? Soil moisture estimation. It will look to you very easy, but do you know that in India we have a national agriculture crop insurance scheme? How crop insurance scheme is functioning? How? Based on certain data informations that drought will not happen, or drought will happen, or stress will not cause plant death, or stress will cause good plant cover, or soil health will lead to entire plant damaging or not. These are the one starter box is the ground cover. Based on this is soil moisture indication. A lot of things are happening. And this ground cover particular startup is using this particular knowledge of soil moisture indication promptly, second by second, that it is using for ensuring your crop. $1 billion industries in India you will find the crop insurance business. So this is where it is adding device. I have this much only to talk to you. Thank you very much. Again, I am thankful to all of you that you invited me. I have presented these slides in several forums. So I got opportunity to present before you also. So I'm thankful to your wonderful Vice Chancellor. I'm thankful to your Principal Investigator Nahed, all the Nahed team members, all the organizing committee members, and my good friend Dr. Praveen, and other faculty people, and the students, all of you. I'm so much thankful to you. Thank you very much. I'm done with now. You can have your queries or otherwise.
Thank you very much, sir, for giving a nice information about the digital soil health management by giving the different examples of different apps and digital tools like Mitra, Rashta, and Anjali's app. Thank you very much. May I call upon Dr. Shinde sir to felicitate today's speaker, Dr. Vijendraji, by a bouquet and moment of his.
No question, huh? Don't want to ask me questions. I like questioning. Last minute. Student particularly, you have no idea from this lecture, you can ask. So many questions, huh? Thank you very much.
Thank you, sir. So the speaker of the next session is Dr. Ravi Narayan Sahuji, Principal Scientist, IARI in Delhi. And reporter for this session is Dr. Praveen Vaidya sir, Head of the Department, Soil Science and Agricultural Chemistry. So may I request Dr. Praveen Vaidya sir to chair the session. We are going to demonstration. Thank you very much, sir. So all participants are requested to gather at 4 o'clock in the same hall for the next session. Thank you very much.
Hello, all the online participants. We are visiting the NAPS center, so be tuned. कैमरा बंद करूंगी, माइक बंद करूंगी।
This is a Indian Marshall Agriculture Research Project, which is formulated by ICR, and this project is aiming to make all of you PG and PhD students literate to a very higher side, which is now a scale of our. Now, whatever we are learning is a tradition. हम लैब में जाते हैं, जो भी देखते हैं पढ़ते हैं, तो साइंटिफिक वही पढ़ते हैं, वही भी देखते हैं। आपको नयापन भी नहीं, आप में नयापन और आप में एक उत्साह जगह की, जो हम जिसे नाहक बोलते हैं, that is called National Agriculture Higher Education Project. This project is a short form as a DFSRD. Okay, what is it? It's a digital farming solution for the most important thing. I'll quickly finish because we have to rush around all those things, and we'll get back to the again hall, because there is again big for that lecture. So National Agriculture Higher Education Project, ICR, formulated. This is a caste center subsegment. Caste means CAAST, Center of Advanced Agricultural Sciences and Technology. Okay, this project is totally devoted for digital technology application in agriculture. Now, every one of you have a subject fertilizer field, and your intervention of digital technology in your subject is सबके जाएंगे तो digitized फॉर्म में पेट्रोल बनते हैं। गाड़ी चलाते तो गाड़ी की भी अभी डिजिटल फॉर्म में आपका कितना लीटर पेट्रोल कितना सब आया है, ठीक है। So digitization, why is it required? Because तो उसी समय आपको व्यापार होना भी ये आपको सोचना जरूरी। तो scouting of weed, getting scouting of pest and their control. If you want to do some analysis that how many number of plants are there in the field on your mobile, if you farmer is looking at this the screen कि मेरे खेती में 7,500 पेड़ है, अच्छा लगता है. उसके बाद बोला जाए 7,500 पेड़ के ऊपर 15,300 फल है, अच्छा, बहुत अच्छा लगता है कि नहीं. So everywhere it is quantified. So next to that is that if some fruit is getting cut, okay, what usually farmer do the spraying on a whole field farm. So pesticides yes, just we don't. Everywhere it is expanding. So in the field, we are optimizing that out of 7,500, suppose 15,700 fruits are there, amounts to which number of fruits, because every fruit is given number by this camera and scanner. So you will get no key 1,750th fruit number wherever it is located. There the robot has to go and get scanned. Okay. So only that much of spray and the pesticide will be used. So if you count down for the farmer, the entire spray pesticide in the field of one farmer, in the field of all farmers including in one village, and all villages including one taluka, all talukas including one district, and so on. So looking at this also, you are going to minimize and optimize the use of pesticide. एक फर्क है कि आप जैसे वैज्ञानिक तरीके से जो काम कर रहे हैं, आपके जो ज्ञान की पूंजी है वो इस तरह से लगानी है कि जो भी तकनीकी इस्तेमाल का आप इस्तेमाल करने के लिए किसान को प्रेरित कर रहे हैं, तो उसको ये पता चलना चाहिए कि मैं आपके इंडिविजुअल खर्चे से कितना बचाव हो रहा है, उससे देश का भी कितना बचाव है ना. तो सबके आमदनी से ही फिर देश की बुनाई होके अपना जो देश की आमदनी हो बढ़ेगी, तो ये आपकी करेंसी बढ़ेगी. तो किसान का जो व्यापारी तत्व है देश की we must to be a very much तो आप आपने ज्ञान आपके जो थ्री डी प्रिंटर, आपको 2D प्रिंटर जो कागज प्रिंट होके निकलता है, इस प्रिंट होके निकलती है कोई वस्तु जो बोलते हैं ना ऑब्जेक्ट, वो प्रिंट होके निकलता है उसमें 3D, because it is volumetric along x axis, y axis and z axis, all three axes you get one volumetric object as a print out, है ना. तो ये जो 3D प्रिंटिंग है उसका इस्तेमाल रोबोट्स के कंपोनेंट्स, ड्रोन्स के कंपोनेंट, जो भी आपके तकनीकी ज्ञान में जो चीज सही होनी चाहिए आपके दिमाग से या बदलाव होनी चाहिए आपको, जो रिसर्च का अटेम्प्ट है वो बढ़ावा करने के लिए जो भी आप करेंगे वो सॉफ्टवेयर टेक्नोलॉजी में. हमारे लिए ये बहुत अच्छी बात है कि हमारे पास कैडमियम जैसी लैब हमने एस्टैब्लिश की है, जिसमें आप सॉफ्टवेयर को इस्तेमाल करते हुए बहुत सारे ऑब्जेक्ट्स आप उसमें बना के लाइवली देख सकते हैं कि ये कब टूटता है, ये कब पिघलता है, ये कब खराब हो सकता है, कब You have to be expertise in knowing all those things, है ना? आप खुद के किचन में कोई साउथ इंडियन बगल में है तो इडली भी जाके खाते हैं, कोई राजस्थानी वाला ढोकला भी खाता है, ढोकला भी खाता है, समोसा भी खाता है, क्यों खाते हैं? You are getting a knowledge of varieties of every kind of food to taste it. So for digital technology, intellectual application सब कुछ जो है इसमें हमको ग्लैड की छोटे-मोटे जॉब को नहीं जाना. You have to have a knowledge of it. Definitely going to teach you a very smart and higher salary oriented jobs. यहाँ पे climate based के लिए हम सेंसर्स का इस्तेमाल करते हैं, जिसे CD केस कहते हैं, climate based decision knowledge support. So accordingly, that is a portfolio. Here we have separated this as a subset. Here you will learn all types of cameras. You will see कैमरा जिससे हम पता कर सकते हैं कि जो वाटर कंटेंट एसिडिटी कितना है, मॉइस्चर कितना है, टेम्परेचर कितना है. ओके, so all kinds of parameters you will understand. Now more than that, you will have to have a small automation system. किसी भी किसान को, छोटे किसान को उसके मोबाइल पे ज्ञान होना चाहिए. मुझे आज अभी पानी देना है, कितना देना है, मुझे आज खाद देना है, कितना देना है, न्यूट्रिएंट्स कितना देना है. Second thing is that so you will get these different types of plants to grow and develop. हमारे पास एक रोबोट है जो क्या करता है, ब्रिंजल प्लांट के ऊपर टोमेटो ग्राफ्ट करता है ना, तो व्हाट वी कॉल इट एज अ ग्राफ्टिंग. तो you know, you have to have sometimes there is a different kinds of combination with the genetic formulation. You can do different types of grafting and you can get them transplanted into the field, grow it up and check the difference in the food, how it is grown. And if you find something new, that is your innovation. If you find something useful, that is your income. If you find it is to be marketable, that is your income. So source of all get out of withdraw out of the technology for the sake of a farmer society. तो यहाँ पे आपके जो सारे कहीं क्लिप बदल दीजिए, कहीं पे किसी भी पार्ट्स का कंपोनेंट्स का आप जो ग्राफ्टिंग करते हैं उसमें मैक्रो ग्राफ्टिंग भी सपोर्ट. तो उसके लिए ये इसके रिलेटेड जो मशीनरी टेक्नोलॉजी हमारे यहाँ साउथ कोरिया का एक रोबोट है, जापानीज कंपनी का भी रोबोट आ रहा है, उन्होंने इंसिस्ट किया कि हमारे साथ. तो आई वांट टू से जस्ट सो कि जिसका इस्तेमाल किसान कर सकता है. मानो कि किसी भी किसान के खेत पे आज हार्वेस्टिंग हो गया, उसको क्लीनिंग करके, ग्रेडिंग करके, पैकिंग करना है, तो ये so Ola will make the corn formulation of 1 village 1 day. तो वैसे ही ये डिसीजन मैंने आपको ये स्प्रेयर प्लांटर ड्रिल बिट करेगा. नेक्स्ट इसमें प्लांट जो है वो पेपर शॉट मैकेनिज्म आप यहाँ पे प्लांटिंग कर सकते हैं. सिमिलर this is one of the new attractions for food processing student. We are introducing 3D food printer. printer, just like the
audio. जा, जा, जा.
आप इसके आप चाहो तो कोई डिजाइन करना है तो करो. It will work like this way and this way. It will go like this way, this way. Whichever the way you like, you can check and change the modification. And you can make the modification. So here, because if see, I am only speaking, you will get bored. So I have to introduce the engineer. He will explain you about vegetable parts and close by. It's like a slit. You see the sprayer and sprayer but you can keep it. What is this butter for? Going to 1 lakh. 1 lakh. Camera. और ये चलेगा कब पीछेगा पता नहीं. बच्चे की हरकत होती है थोड़ा सा हवा में चलने वाले आपको पैटर्न होगा
मोबाईल ग्राम
तेवढी गृहीत धरा आणि वायफाय असेल तर ते कुठं नाही मोबाईलला वायफायला तुम्ही if you are using Wi-Fi, you can run it from home because that is team connected. Team से connect होगा ना तो team जैसा ऐसा चलेगा Yeah, it is connected with the mobile. The team connected ब्लिंक सॉफ्टवेयर वो जो ब्लिंक सॉफ्टवेयर है उसको हम ऑपरेट करते हैं नवीन प्रकार आता तो फील्ड में घूमेगा और घूम घूम करके जितना काम करके आगे वो बोलेगा आपका ही जो मोबाइल में रहेगा जैसे ओला का बिल आएगा टैक्सी का बिल आएगा और तुम्हें बच्चे तो मीटर का बिल आता है वैसे ही इसका भी जो या दिन का चार्ज होगा 900 रुपये तो 900 रुपये इसका प्रायोरिटी ये है कि इसमें ऑटोमेशन होने से इंसान को पहले 25 पे ले जाना पड़ता है या तो फिर ट्रॉली पे ले जाना पड़ता है लेकिन मैनुअल बहुत ही पड़ता है अब ये मैकेनाइजेशन होने से क्या होगा आसान होगा आदमी कितना ही यंग जनरेशन की जो ताकत तरीका the next generation game. So we will go to the next. मैं यहीं पे बताता हूँ अभी आगे जाएंगे पहले एक एक बता दें तो देखो सिर्फ दूसरे पैटर्न पिकअप ओके पैटर्न पिकअप ऑल जो था कॉटन का उसके अंदर स्किन करके अंदर goes inside and this web is having 15 kg 1 घंटे में 15 kg वो चुगता कपास लेकिन इसके लिए एक आदमी लगता है जो वहां जाके कॉटन बॉल के सामने रखे है ना कॉटन को ऐसे निकाले बैग में डाले और फिर बैग लेके घूमे तो तो ये आसान नहीं है। आपका 100 फीट तक भी पाइप जा सकता है। It can go up to 10 feet. Sorry, not so 100. It can go up to 10 feet. So up to 10 feet of distance, the work done will be this. ये जो कपास चुगने का मशीन है सबसे यादगार बन गया। अभी 500-600 इंच कपास चुगने चुका है। बैटरी चलेगी, रात में लाइट भी चलेगा सोलर वाला। तो ये 12-12 चार इधर से ले सकते हैं। इधर ये साइड में आप आधा थोड़ा बीच तक ले रहना। एक दिन में 120 to 150 केजी इसका टैंक दिया वाला है। You can see from the back side. चलो जल्दी जल्दी, अभी ट्रैक्टर और बहुत सारा देखना है। चलो जल्दी जल्दी। आगे जाएगा जास्त फुटर असलेला म्हणजे
रवि सर जूम चल रहा है? चल रहा है। क्या ड्रोन के बारे में दिखा क्या मेरे पास भी दिया
सब लोग देखो, सब लोग को ड्रोन अभी एक शॉर्ट फॉर्म में
तुम मध्ये काय ते मध्ये
व्हाट डू वी कॉल इट एज अ प्रोपेलर। तो क्या कहते हैं? प्रोपेलर। हाउ मेनी दे आर? 4 प्रोपेलर, 6 quadra. Okay, if it is 4 quadra, if it is 6, if it is 8, okay, and if it is 3, tricopter. Okay, if it is 2, bicopter. Okay, usually foreign में अभी पूरे वर्ल्ड में more than 10,000 companies are entered. They are doing every day new innovations. What is our aim? Our aim is to either connect the camera and get scan of the field and get the data back and let you have that data for your processing, so that you will know कि यहाँ पे कौन सा पेस्ट आ गया है या कोई प्रॉब्लम आ गया, हेल्थ कंडीशन बिगड़ गया या अच्छा है। क्रॉपिंग का एवरीथिंग यू आर यूजिंग कैमरा और यू आर यूजिंग स्प्रेयर। ओके, तो यहाँ पे आने के लिए इसका लाइसेंस नहीं मिलता है, वो आपको ट्रेनिंग लेने के लिए कहता है कि आपको 8 से 15 दिन तक का ट्रेनिंग लेना पड़ेगा, जिसकी फीस 60 से 70 हजार है। और वो ट्रेनिंग के साथ आपको पढ़ना यह है, ड्रोन को चलाने के लिए आपको क्या चाहिए, उसका नॉलेज। तो यहाँ पे 2 नॉब्स है, देख रहे हैं आप सब, ये 2 नॉब। ओके, नाउ टू स्टार्ट दिस वी आर सपोज टू मेक देम क्लोज। ओके, इधर लिया मैंने, इधर दोनों को भी मेरी तरफ ये ऐसा ले लिया मैंने, ऐसा देखिए, ऐसा ले लिया, ऐसा है ना। ओके, लाइक दिस। नाउ दिस हैज स्टार्टेड द प्रोपेलर एंड दोस ऑल मोटर्स। मोटर्स कौन से होते हैं इसमें? ब्रशलेस डीसी मोटर। कौन से? ब्रशलेस बोले तो बीएलडी, क्या बोलते हैं उसको? शॉर्ट फॉर्म बीएलडी। इसके अंदर आपका जीपीएस सिस्टम भी होता है, तो वो आपका जीपीएस लोकेशन तय करने के लिए। Okay, in this field, you have to learn how the electronic components are to be designed. जिससे आपका एक कंट्रोलर बनता है, जो कंट्रोलर माने उसका माइंड, उसको उड़ाने के लिए, उसको ठीक तरह से चलाने के लिए। अब ये जो नॉब है सब तरफ सब इधर देखो, ये नॉब जो है इसका इस्तेमाल हमें ऊपर उड़ाने के लिए, नीचे लेने के लिए एक नॉब, फिर लेफ्ट टर्न लेने के लिए, राइट टर्न लेने के लिए एक नॉब, है ना, और उसी जगह घुमाने के लिए क्लॉकवाइज और एंटी क्लॉकवाइज के लिए उसी नॉब का इस्तेमाल किया जाता है. ओके, एंड एवरीथिंग इज कनेक्टेड टू द मोबाइल or it is connected to the LCD. So you will let know here how these all things are to be captured. Okay. So Maruti, he is a technical expert. Now he will just start and he will immediately show. You look at his fingertips. उनके fingertips की तरफ देखो वो क्या कर रहा है पहले. हाँ, ये देखो ये ऊपर ले रहे हैं, ये ऊपर ले रहे हैं, ठीक है. अभी इतना सेंसिटिव है, देखो इतना सेंसिटिव है. घुमाइए ऊपर जाएगा कि नीचे आएगा, ऊपर जाएगा. देखिए देखिए ऊपर जा रहा है. अभी ऊपर नीचे ला रहे हैं, क्या करना पड़ेगा मुझे? देखो ओके. अभी तो यहाँ पे जो उसका जाते हैं
शिपायाला हॉल मधले हॉल नंबर 18 मध्ये डबल सरकवले ना मी, ते केले ना मागचे पुढे समोरची पूर्ण दोघच जणांनी कल्याणानं मी
उधर ले जा रहा हूँ,
नाही
उधर ही ले जा रहा हूँ, ठीक है.
एक दिवस
अभी
पहिले
मैं इस तरफ ले जाऊँ,
झाले ना बरोबर. आता आता कसे आहेत बरोबर रेंज.
सी
हे यानं करायला पाहिजे तो हॉल नंबर 18 वाले ना, ते आणले तेव्हापासून कोणतरी लावले, ते राहिले तसेच.
डिपेंड करते हैं याच्यावर दोनच्या कंपोनंट. ठीक आहे. आता मी याला खाली याला बघा, मी खाली इकडे घेतला तर कुठे जातो बघा. हे बघा 4 डायरेक्शन. ठीक आहे. आता फक्त मी एक सांगतो, याला वर बघायचं, वर. हा 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 राईट साईडला करा. काय झालं? बस दमान दमान, जास्त नाही, थोडं थोडं थोडं. हा बस लगेच सोडायचं. थोडं हा बस 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 सोडून द्यायचं. ना आता ह्याला खाली काय झालं बघा, ह्याला वर द्या, वर नाही आता जास्त नाही, थोडं थोडं. So these four direction of motion is okay. You got this right. Come on. Ela वर घे, वर घे. हाँ. Yes. अब ये ना वर. आता खाली घे, खाली. बस. आता याला घे ना, पलीकडे. हा घे थोडं. डायरेक्शन है ना. हाँ ठीक है. याला धक्के नाही जमत नाही. आता याला लँडिंग करताना बघ.
काय हा हो मी तेच म्हणालो. म्हणा ना.
प्लेन सरफेस काय दिख रहा है क्या आपको? नहीं दिख रहा है. हाँ ठीक है, हाँ ठीक है। अभी मुझे इसको लैंड करना है, तो क्या करना पड़ेगा? क्या करना पड़ेगा? लैंड करना है, अपने की तरफ करना है, अपने की तरफ करना है ना? कौन आएगा अभी? अभी इसको है ना, हो गया हो गया, जस्ट लास्ट लैंडिंग लैंडिंग। अभी इसको है ना, हाँ, Okay, this is a smooth landing which we, this is a smooth landing, and when you take off you have to lift it. Okay, so today you have learned the roll function, how is it to be taken off and how is it to be land, how is it to go right, left and landing. Okay, chalo hello
काय बघलं अरे झूमवर चालू आहे आपलं लाईव्ह प्रक्षेपण
हे पण ऑनलाईन आहे का?
मैनुअल ऑपरेशन है, ठीक है, एक फोटो ले लीजिए आगे
करोड
चला जल्दी जल्दी अरे यार सब आ जाओ, नहीं तो आधा अधूरा होता है।
थैंक यू।
अभी आपको उधर जाना है ना, क्लास है आपका, आधा जो पार्ट कल कवर कर लेंगे, आधा बहुत अच्छा है, ठीक है। अभी सबको सबको 8 नंबर में जाना है। देखो अभी हम ना, अभी क्या करेंगे, पहले आपका सेशन खत्म हो जाए, फिर कल या आपका जो टाइम खाने का होगा उसके पहले या उसके बाद में जब आएंगे तो आपसे हम ग्राफ्टिंग करवाएंगे, प्लांट 2 प्लांट को इकट्ठा करवाएंगे, है ना। तो वो देखने के लिए आपको आना पड़ेगा कल, एक घंटे का समय निकाल के। तो अभी सब सेशन वहाँ पे वेटिंग में है और वहाँ बाहर से वो ज्वाइन हो चुके हैं, तो यू हैव टू रीगैदर टू 18 नंबर। ओके, सब 18 देखो सर किसको ना रहे, तो 18 नंबर में सब चले जाओ, अभी कोई भी नहीं रुकेगा। गाड़ियां जितने हैं वो निकालो, जल्दी जल्दी बैठो गाड़ी में, चलो चलो। 18 नंबर सोडून दिला, आता उद्या अर्ध उद्या चलो सब लोग है ना, हॉल में चलो जल्दी। वहाँ एक हमारा ग्रुप फोटो होगा वो स्पीकर्स के साथ, और 18 नंबर में सबको रीगैदर होना है वहाँ।
Yes, but proper.
हेलो डॉक्टर कैलाश डाकोरे जी
सर ऑनलाईन आहे. ऑनलाईन. हॅलो सर ऑनलाईन नाही आहेत सर.
ऑनलाइन नहीं है का?
नाही आहेत.
ऑफलाइन है का आता?
नाही लेक्चर ऑनलाईन आहे, सर नाही आहेत ऑनलाईन.
सर ऑफलाइन आहे म्हणजे आताचे प्रेझेंटर?
नाही ऑनलाईन आहेत सर. पराग सुतार सर.
आता पराग सर आलेत का तिथं?
नाही ऑनलाईन आहेत.
18
ऑनलाईन
नंबरला आलेत का?
ऑनलाईन आहे सर.
ओके, मला मग चालू होण्यापूर्वी
हो होतंय सर.
ठीक आहे,
लगेच
मी
चालू.
ऑनलाईन आहे.
हो. हॅलो सर. हॅलो हॅलो. नाही पराग सुतार सरच आहे पुढचं. हॅलो हॅलो वायकर सर. नंबर लागत नाहीये. हा नाही आगरकर सरचं काय म्हटलं तू रवी? अवी तो फिर वो रैपोर्टियरशिप कैसे करेंगे मैम? आता कोण करते मैम आता तुम्ही करता का अँकरिंग? मॅम अँकरिंग तुम्हीच करताय? सर ऑनलाईन आहे का? हा हॅलो सर. हा सर तुम्ही मीटिंग मध्ये आहात का सर? हॅलो सर. हा सर तुमची रॅपोर्टियरशिप होती सर.
Mic was operated. Mic was operated.
No.
Good afternoon. Welcome you all after the practical session. Now, the speaker for this session is Dr. Parag Sudarshan, Department of Food Process Engineering, National Institute of Technology, Rourkela, Odisha, India. And the reporter for this session is Dr. P.S. Agarkar. Before inviting him for this presentation, I took this opportunity to introduce him. He did his UG from Dr. P.D.K. Vyapola, Masters from G.D. Pant University, Agriculture and Technology, Pantanagar, PhD from Indian Institute of Technology, Kharagpur. He honored by different awards like National Doctoral Fellowship by All India Council of Technical and Education, New Delhi, for his PhD program at IIT Kharagpur. He did his postdoctoral fellow in chemical engineering. He also did many national and international trainings. During his research, he wrote different research articles. He wrote more than 18 research papers, different book chapters, and many sponsored projects. He is working as a member research council in Anand Agriculture University, Anand. So I took this opportunity to call Dr. Parag Sukar sir for the presentation on the topic automation of electromagnetic energy. Processing machinery. Dr. Sukar sir, please.
Okay, am I audible properly?
Yes, sir.
Hello, am I audible properly?
Yes. You are audible.
Please start your video, sir. Parag sir, please start your video.
Okay. Am I audible properly?
Yes, sir. Yes, sir.
Okay, thank you very much for inviting for this workshop. And, I would like to talk on the automation of electromagnetic energy assisted post-harvest processing machinery. So my presentation is there. Okay. So my slide is visible.
Yes, sir. Visible.
Okay. So automation of electromagnetic energy assisted post-harvest processing machinery. There is a lot of advancement in this field, post-harvest machinery, processing machinery. As you all of you know that there are so many unit operations, drying, dehydration, post-harvest handling, sorting, grading, then farm cooling. So many unit operations are there. Now, what is the actually need of the automations in the agriculture? You can see from here that there is a rising need for automation systems in the agriculture industry due to increasing labor costs as well as some other opportunities in the Asia Pacific, particularly country, and they are attracting the robotics in the agriculture. And there is also growing population shrinking workforce that are fueling robot adoption and thus acting as a key driving factor of the market. Then there are the rising investments also in the robotics, such as drones, automated harvesting systems, driverless tractors, etc. Increasing needs for agriculture automation will really provide a great opportunity to software and the service industries. And there is always one word robot, so I will would like to explain that robotics also here. The use of real-time multimode systems in the field is also expected to fuel this growth. Now you can see that there is the agri-tech. Okay, so agri-tech. There are so many things in this new field: Internet of Things, smart farming, precision farming, robotics automation, vertical farming, biotech, big data and artificial intelligence, drones and satellites. But everywhere there is the one common thing, that is the coding and the sensors. So sensors technology and monitoring solutions integrate all these existing farming processes and generate the precision data for daily decision making. So like a farmer, when he is taking daily decisions, actually farmer is, or any person who is working in the agriculture, he is sensing the data by his eyes or other senses, and then he is taking the decisions. So that has to be converted into the now sensors and automation instrumentation. So sensors are very important things in this. Then drones and satellites, this is another field that other people may be talking on this in this workshop. Then big data and artificial intelligence, biotechnology, vertical farming, robotics, automation. Let's jump to our field, food processing engineering. So why there is a need of automation in post-harvest handling or post-harvest processing, and where urgently it is needed, and where this is actually really being followed. So you can see that there is a Salmonella species, S. aureus, Bacillus species, Shigella, right? So these are the microorganisms. They are present in the different food products. Now, whenever you are from India or any other countries, if we are exporting these food products to the USA, European countries, they are very cautious about these microorganisms. And after COVID, they are very serious. Now, question is that what is the relationship of this automation industry and these microorganisms? Before COVID also, there was automation required in this industry, right? So there was a manual mode of operation leading to the poor control and lethality of microbes. Now, what is the lethality of the microbes? The lethality of the microbes means, I will show you one product, then I need conference. 5 minutes. So you can see these are the products. Okay. So these products, these are the canned products, and they are supposed to heat or cook in these autoclaves, and then these canned products has to be sent to the USA. So in USA, you can see that maximum people use can and retort pouch products, and they are sterilized. So what is the sterilization? You have to kill all those microorganisms. Now, how you will be sure that all microorganisms have been killed? So killing of the microorganisms needs the heat treatment, but that heat treatment, exactly, many people may be there in this conference who knows about this. Killing of the microorganisms need particular temperature. Anyone having idea? So it is a 121.1 degrees Celsius is minimum temperature required for ensuring the death of the microorganism. But what is the time? And in reality, it happens. That how you will know, and how one can understand that, okay, that number of microorganisms have been killed, and then that door of the equipment should be open. So who will take that decision? Manual mode of the operations gives poor control on lethality of microbes. Means that person will decide, and if he miss something, he will use actually that product will be under process and some microorganisms will remain there. And when that product goes to the export market and when the people open that packet, they will find the microorganisms. So that becomes dangerous. So USFDA is very strict, leads to rejection by USFDA and European regulatory bodies due to the food safety issues. And there was a 6 years we had seen that data, you can see on the internet also, 13,000 around items were rejected by USFDA in 6 years. So for automated solutions, foreign companies now, there is a question. They are saying that, okay, if you want to export these cans to the USA, then you buy equipment from USA, which is complied with fully automated solutions and the softwares, which take care of these microorganisms death. Right. So what is the death of this microorganism? How it complies? Then I will show you some data. Before that, you can see that USFDA and FSSI. So in 2010, 2011, 12, 13, 14, 15, total refusals were like this, I already showed. And many were from maximum India and some other countries also get refusals. So in this case, suppose these are the cans, this is the steam autoclave, cans of different products, peanuts, then you can have corn, sweet corn, tomato soup. So n number of products are there. They are canned, sealed, and then put in the steam autoclave where temperature is given 121.1 degrees Celsius. But here there is a problem. Suddenly 121.1 degrees Celsius temperature at the center of this can, is it possible? It's not possible. Then the temperature goes on increasing slowly. It takes 30 minutes, 40 minutes. Then constant temperature will come, suppose 120 or 115, 118 degrees. And then there will be the sterilization and then there will be the cooling. So these are the actually systems, automated systems. That is a JBT, what I told you. That this equipment is being imported in the India for exporting the product to the US. So whatever we export product, again we are buying back their equipment because of the lack of this technology here in India. So these are the automated batch systems. These are very huge systems where packaging, loading, unloading, multiple operations, even millions of the cans are sterilized in this system. But this type of the systems are not available in India. Now these are the other automated batch retort systems. These doors automatically open when actually sterilization is completed. Now question is that how this equipment is deciding. They are giving the equipment, pipes are there for steam flow and the water flow. Steam is supplied by that manufacturer from the boiler. Then cans are loaded here, door closes. Then they say that okay, steam should come at 121 degrees C, or that more than 2 atmospheric pressure in this retort system. Then it should hold, it should rise the temperature, it should hold there, and it should get cooled down. And that calculation has to be matched in the computer by using the census data. That temperature has been reached, it was increased, hold at 121 degrees C, and then cool down. Then that door will open. But if this steam flow is less in between, this is a practical problem. Okay. So in this case, what happens? This equipment doesn't open the door unless that time is increased to make up the loss of the lethality in this process. So I already told you that you can see that lethality of microbes. So it doesn't open. So this is called as the automation. This takes the own decision and this is already feed in the system. Now these equipment, for example, this JBT food tech, this is in compliance with this US FDA guidelines, and their software you cannot make changes, and that save the data, in their server, and that server data directly can be transferred to the US FDA. Then they believe that, okay, in your factory, from checking that data, they believe that in your factory equipment that processing was right. Even if your steam supply is low, it will increase the time and it will definitely achieve the lethality, means killing of the microorganisms. Now, how many microorganisms are there, and that we'll see further. So now we'll come to the electromagnetic energy. So this is the steam. We directly jump. Initially, we started working with the steam, but nowadays, working with the steam itself is a expansion. So people in India, there are some manufacturers or some industry, small scale industry, they requested, okay, find a solution where we can actually kill the microorganisms, and we don't want to install the boilers. Then we found that non-ionizing and ionizing radiations are there. So electromagnetic radiations, microwaves, infrared, and ultraviolet, these three are useful for killing the microorganisms. Now, question is that wet food, dry food. So currently we are working on the automation of the microwave, infrared, UV assisted sterilization of dry products. So dry products like spices, different cereals, they are also exported to the USA, and they found that, okay, there is a load, microbial load 10⁶, 10⁵, salmonella. So some loads are there. So they say that you have to decrease those loads and give the data. Now, in that case, what we have to do? We have to do simulation and optimization, micro-infrared UV systems, lethality calculations, but at the same time, absorption phenomena, microbial quality, other chemical, physical, glass transition, everything has to be considered. So it becomes more complicated. But this part I am not covering. I will cover only automation. For that purpose, just what I was telling about the sterilization, let's see what is that means. Completely sterile food, this is not practically possible, but acceptable reduction in microorganisms. So D value is one concept, decimal reduction time. Suppose there are initially 10⁵ microorganisms, and if you hit that product and it becomes 10⁴, then 1 log reduction is there. So degree of sterilization is sterilization value. So 12D means 12 decimal reduction. So 10⁻12 to directly 1. Now, suppose this is a can and there are 100 spores per container. And if you give if you give 6D sterilization process, means now that temperature time combination in that retort, we'll go back, just you can check. In this retort, for example, this is a can, and if you want to go for the 6D reduction, and initially every can is having like this 100 spores. Then after 60, it will be 0.00100. So 1 spore per 10,000 container will be remaining. So this is the assumption and calculation, right? So 100 spores 12D, then 1 in 10⁻10 containers will be having only 1 spore. So that is the acceptable limit and it is safe. So how to achieve? So you have to go for the decimal reduction, this parameter calculation, initial microorganisms and number of microorganisms remaining after your time. Then you have to find the equation. Then you have to find actually time of sterilization. And if your time is not exactly 121.1 degrees C, in retort, which is practically not possible. It needs some time to increase the temperature from room temperature to the 121 degrees C, like this. Just a minute. So temperature rises like this. For example, from 50 degrees C, it will heat, then you will hold at 121, and then it will come. Now this graph is used to calculate the heat penetration parameters. And these parameters are calculated from this graph by US FDA. When you are sending your product and you are saying that, okay, this is a sterilized can product of India. So they say that give us this chart. So any random they chart open, they calculate whether your all these heat penetration parameters are correct or not. So these heat penetration parameters they calculate, and if you pass, then they will allow. So it means that you have to find the D values, F values. That is the time required at a reference temperature to achieve the desired sterilization value. But will be varying temperature and time combination. So here you need an automation. Already international companies they are having the automation. So thermal process and data analysis becomes very important here. Now recording the temperature at slowest heating zone of the cans, then retort temperature should be at constant at 121 degrees C. Cut off the steam when you want to start cooling process, estimate the overall F value, and then find selected value. So I will show you one. This is the data you have to collect from the sensors. So you have to insert the sensors in the cans, collect the data, analyze the data, and again give back signal to the retort that this process is completed. Now you can open the door. So this is a cumulative. Now this is in lab. We did one trial. Now I will show you the actual what happens. So this is a retort. This is one sample of one company. They are doing this retort sterilization, heat penetration. Okay. So these JH, FH, these parameters are calculated, right? Then for that, I will show you this video. Okay. So you can see how this automation is done. So that has to be done here. This is not our process. This is the one sample I am showing you. These scans are automatically, all these timings are set. Then these scans enter in this horizontal retorts. So you can see that door is open and the scans are coming out also. So these combinations has to be taken decision from this calculations. So this automatic opening of the door and this closing of the door, it comes from here, right? Now for that purpose, there are some regulations. So I will take you to that US FDA regulation, and then we will come to our approach, how one equipment already developed at our laboratory. Now you can see this federal code. Code for federal regulations. You have to go there, and you will find there all regulations. So they give the exactly what is commercial sterility, critical factors, headspace, incubation, then equipment procedures. So in these procedures, we have to go for the temperature recording devices, analog or graphical recordings, digital recordings, adjustments, temperature controllers, pressure gauges, steam controllers, steam inlet, then thread supports. All these has to be followed as per their guidelines. So they give all guidelines how to carry out and how to take the data and how you will again do the automation. So that all each and every guideline is given here. You can check. Then we will go to our presentation. So let's directly come to our equipment. This is first micro infrared UV continuous sterilizer for spices. So this is a dry sterilization unit. Initially, I showed you redotting, that is a wet sterilization unit. This is a dry one. So feed hopper is there. This is the micro system. Inside it is a closed. Product goes and gets heated by the microwaves inside this, and then comes here in the UV chamber. You can see that 1, 2, 3 feed hopper IR power system. 3 screw conveyor. It is inside. Then 4 is our control panel, UV light power supply, vibratory cooling chamber, bottom, then outlet for product, springs to assist the vibration, screw conveyor motor, micro electro control wall, vibratory motor, transfer box, camera. So inside you can see that magnetrons are there. In the micro oven on the right hand side of the wall, you can see that the magnetron opening is there. From there, microwaves enter. Here 1, 2, 3, 4 magnetrons are fitted to this cavity. Directly you can heat the product, and this is the conveyor where these spices like black pepper or leaves, they keep on moving. So this is the capacity of the sterilizer. 4 kilowatt micro, infrared 4 kilowatt. UV lights 100 to 290 nanometer. There is another post-harvest equipment which is developed with this instrumentation, paddy processing unit. So this is a paddy parboiling unit. I have already one PhD has completed. So first our step was the instrumentation and controls in the equipment only. Second step is the automation. So first step we have already completed, that we develop the equipment with all instrumentation and sensors. So right hand corner you can see that drum and water is sprayed here and paddy is put in the drum, and then there is a paddy moisture absorption by the paddy, like overnight soaking of the paddy has been replaced here by 30 minutes addition of the moisture. Then cooking of the paddy is also replaced. Traditional cooking of the paddy by steam also replaced here by the micro heating, and drying of the paddy on the large platforms is also replaced here by this equipment. Now infrared peeling. So this was a advanced stage combined tunnel micro infrared UV conveyor belt cum sterilizer dryer. Now you can see that a lot of sensors we are using here, and the doing the interface with the magnetron system, power system, and a lot of electric wiring we are doing. So this is first a tunnel, right? It is a belt conveyor which is moving in this tunnel from this direction, you can see, and this is the from side view. You can say that inside the tunnel there is a belt conveyor, and in the tunnel we have fitted the infrared. Again, from their infrared sensors, temperature, its temperature, then humidity sensors, they are taken out. And now this circuit is made and control panel is done. So then we connected this to the microcontrollers. There are PLC controllers also and this also. Data logger also you can take. So data logger is ready-made available, but it is expensive. If you want to make your own system, then you can buy your microcontroller and the sensors and connect all these and get it on the computer screen. So this is not our equipment. Equipment 1, 2 is our. So we are taking it to the first round. We are having the data logger, and from the data logger also you can do automation. It becomes easy. But for automation, you need to send the signal to the power system. Suppose in this case, here infrared heating of the product is going on to kill the microorganisms, and if temperature exceeds, then there is a temperature recorder which is giving temperature, showing temperature here. If temperature exceeds, suppose 121 degrees C, then that program initiates and send the signal back to the equipment to switch off this power system of the infrared. So this power system of infrared is connected, and there has to be relay switch. Even there are some relay switches here. You can see side. Okay, there are relay switches here. In case in between somebody is opening this door, then microwaves will come out and there will be the accident. So the moment you open the door, this will send signal to switch off the microwaves. Now, how to make a software? So in MATLAB, you can make graphical user interface, or many other softwares are there. Okay. So this is actually based on another company's data. It's exactly we are not having the same to same, but we are our master student is doing sterilization process, started operation normal. So we are using the temperature 120 and then shutting down the process, right? So without temperature, NVC, F0 value. So we have to give different alarm systems, then micro power, infrared power, power, temperature, pressure. So these still are under progress. Then we have to add some alarm systems, and suppose chili sterilization is there, right? We have done a lot of work on the chili sterilization. You can see my paper, but all were done manually. Now industries, they are saying that okay, do it automation. So we are developing this program. So presently we have started with the micro sterilization come finish drying of dry spices. So dry spices also have a lot of microorganisms. Now problem is that how to fit the sensors in the electromagnetic radiation units. That is extremely difficult, because electromagnetic radiation, it interferes with this sensor data. So to protect it, suppose this is the outlet of the air, a lot of humid air and temperature is coming. So from the change of the humidity, we can actually find that whether inside that drying is going on, or only heating is going on, or cooking is going on, right? So sensors, they are already protected by this mesh. Through this mesh, microwaves cannot penetrate. Now, all these sensors combined together in a microcontroller. Then from the microcontroller, we are taking it to the computer. Here there are series of problems we are facing. For example, you can see that the steam is required. As I told you, that steam is always required in sterilization process. In dry sterilization process also some steam is required. Okay. So how to sense the pressure and temperature of the steam? So we added this in between the one box. You can see one box to take the temperature of this sensors, steam through the sensors. But steam condense and create a constant environment, and then that sensor becomes saturated there and it doesn't give the readings. So automation and this sensors technology has to be much in detail. Actually, there is no such a in-depth sensors and supporting instrumentation system research in our country. We have to depend on other German and Chinese. Then you can get the data on the computer. So technical specification, suppose one temperature and humidity sensor is there, simple, right? Now specifications has to be very precise. Humidity 0.1% RH, then that repeatability is how much, humidity hysteresis, long-term stability, sensing period 2 seconds, you want 10 seconds, 5 seconds, then DC that supply is there, then temperature 40 to 80 degrees Celsius. If your temperature goes above that, then what will happen? So all these problems come. Then there is a Arduino microcontroller which is available on Amazon also and internet. This is very common. But in that also you need the voltage and maximum supply voltage. There are different types of the microcontroller. In a small microcontroller, and if you go on adding this is the microcontroller inside this. If you go on adding your sensors in that, it will not work. You have to select the right microcontroller which can take the data, and then what is the flash memory. Based on that and DC current and the DC current input output pins. So this is actually controller, microcontroller, you can see. So we have got this. Then thermal imaging modules are also available with us. So this thermal imaging module, this directly gives temperature profile of the product from where you can take the decision. So measuring this minus 40 to 300 degrees, yeah, our range is there, refresh rate is there. This is in our lab. And microcontroller you have to buy, and you have to connect all these modules to the microcontroller. Then you can take the decision actually. Okay, my temperature, if average temperature goes beyond 121 degrees C, I have to switch off the power and power of the microwave or infrared. So temperature sensors, thermocouple temperature sensors, stainless steel pressure transducer sensors. But unfortunately, these are having the problems in the micro environment. This is the biggest challenge. So we have to cover them with the screen, mesh, and protect them. Otherwise, in the electromagnetic field, current starts flowing in this additional and it gives any reading. Now, where to do the coding? Suppose this is you are buying microcontroller, and how you do it? What is next step? You can go to the YouTube. You will get how to connect the wires, that's it, and sensor. Then you have to connect it to the computer. So computer, you have to go with this software, right? So this is my students right now. I am taking going on. So here you have to do the coding, and you have to set your all parameters. So I will show you. It is there. I have opened this internet. Arduino.cc, you can go and you can download that ID, and you will be able to do the coding directly here in this interface. So there are ready interfaces. Even coding is easy. I was also not coding expert, but after reading you can understand it and you can do it. After that, another thing is that you can have Excel also. So these are the micro drawing of name use continuous data you can keep on getting on the Excel. There are the packages of the Excel available on the internet. where you can take the data of that microcontroller. Suppose our timer, drying time, humidity in, temperature in, humidity out, these were sensors. And then we calculated humidity ratio. So formula were given here, and then density of the moisture, weight of the water removal, cumulative water loss, weight of the product. So from here, actually, you can find as the drying time increases, what happens. So reality is this. Drying rate is, you might have seen that people always show that, okay, after 5 minutes, one data point, 10 minutes, another data point, 15 minutes, another data point. And they plot a straight line or some clear line. But sensors, they give this type of the data. And this is actually happening there. So from this, now next stage is that you have to find why this is coming here in between. When this type of the drying rate is changing, in this code you have to adjust it. If drying rate decreases, increase the power. If drying rate or heating rate increases, decrease the power or switch off the things. So like this you can find. So this gives the real picture, and this is the advantage of the automation. So automation actually helps us to save a lot of energy, to maintain the quality, and to run the process exactly how the theoretical should be there. So like this drying rate you can calculate, humidity ratio, outlet humidity continuously you can find. Now one more thing is that people want it on the mobile. So how to get it on the mobile? So this is a mobile apps coding. So for that, if you have to go to the one easygoing thing is there, I will show you. Go to the studio.code.org. Now, what is the use of this? People say that, okay, this is not our field. They get scared and they run away, right? But this is the block coding. You can easily learn it and make your own mobile link, right? So after this class, I will give you this link of one small. This is already, it needs a lot of inputs, but you can do it block coding. Because I am also agriculture engineering background, I was not comfortable with a lot of coding and softwares and this. Then I found that there are other ways where you can go through the ready software, where they actually help you to make your own code and get it on the mobile. So mobile coding and apps is the today's demand. So I will show you here one demo, right? For example, this is a drying data analyzer I developed just for demonstration purpose. On the farm, there is a large farm, there is a corn and drying is going on. 1 day, 2 day, 3 day, 4 day, you don't know. Or in equipment it is going on and when to stop, we don't know. But initial moisture content is suppose 75%. And if you are having the time of 5 hours, it is a minute actually. So let's take a small experiment. Don't assume as such. Suppose a small experiment, very fast drying has to be done in an equipment on the farm, and initial weight is suppose 5 kg, then it becomes 3 kg. After 10 minutes, then it becomes 2 kg, 1.2, then 0.8, 0.6, so 0.5, 0.45, 0.44, 70. So you can analyze it actually. So it is showing that moisture remaining initially already over dry. So it will show like this. Okay, because it is 75 moisture content. If you say it as 95%, it will show that like this. So actually on the mobile, people want what's going on there. So by using the weight only, they can, okay, they can say that, right? We have to stop here. Immediately they will stop. So this is a mobile coding, and from mobile now sending the signal, those technologies are also there. So farmers, they can operate from their room outside post-harvest processing equipment, which is running in the hot sun. So they can do it from the mobile. Even they can go to some other place and through internet, they can connect themselves to the equipment. So we are actually working on this, and this is actually quite complicated, but there is a lot of demand for this type of the technology. So with this, I would like to wind up here, because I have shown only just 1% of whatever going on here. This is extremely big topic. My several years we are working here, and automation of this post-harvest processing machinery is must to ensure the highest quality of the post-harvest products, as well as the increase the export so that farmers can get more money. So these are the conclusions. So RTE food to be exported needs urgently automation to comply with USFDA. Otherwise, buying very expensive equipment from the USA, Japan, Germany, and the cost of equipment, you will be surprised. It's a 8 crore, 9 crore. So the project is not viable. Then automation in drying saves energy and enhances the quality. Automation in post-harvest handling machinery helps in reducing post-harvest losses. Then in paddy processing can save huge amounts of water and can reduce the effluent. Electromagnetic energy equipment is also must to avoid the heavy power losses. So there are thrust areas. My most important area was the paddy processing. So paddy parboiling was topmost priority, because large amount of water is used to soak that paddy overnight. Then they boil it in big equipment, and then they dry on the big platforms. So extremely energy and water intensive and effluent generating process that was done here. But automation is remaining, I will tell you, because its automation is quite difficult. We have to find the star gelatinization parameters in this. So there are n number of parameters, glass transition parameters. Then these parameters actually we have to study. So my research papers you can check. Sorption phenomena, water activity, glass transition, physical quality, chemical quality, product temperature, physical, thermal, and dielectric properties. So all these has to be combined together for these achievements in the automation. So all these properties keep on coming in the automation process, and this becomes more and more complicated, but we have to go ahead, and that is the future. Okay. With this, I would like to stop here, and questions are welcome. Thank you very much for giving the opportunity. Just a minute. I'm joining from the mobile. There is an echo issue. Please allow me in the mobile system. Parag.
Thank you very much, sir. Thank you very much, sir.
Yes.
Dr. Parag Sutar, sir. I'm audible to you.
Yes, sir.
So, okay. So the next session is, the speaker for the next session is Dr. Guma Murli sir, ICRISAT Hyderabad, and reporters for this session is Dr. P.S. Kapse sir, Associate Professor, Department of Agriculture Extension. So may I request Dr. Agarkar sir to welcome Dr. P.S. Kapse sir by offering a bouquet. And I'm again thankful to Dr. Agarkar sir, who acted as a reporter for the earlier session. So may I request Dr. Praveen Kapse sir to offer a bouquet to Dr. Agarkar sir, who acted as a reporter for the session. Thank you very much. So before starting the next presentation, I took this opportunity to introduce Dr. Guma Murli sir, ICRISAT Hyderabad. Presently, he is working as a cluster leader and principal scientist, geospatial and big data sciences, and also head of the remote sensing and geographical information system unit with ICRISAT. He also working as across Asia and Africa. Prior to this, he was remote sensing specialist and PDF at IRRI and project scientist with IWMI. He is having 22-year experience in remote sensing and geographical information system and their applications to agriculture. His work experience spans over 35 countries spread across the Asia and Africa. So he honored by the different award like Best Team Award for the Global Irrigated Area Mapping Project Team. He is recipient of the Johns Davidson ASPRS President's Award during 2008 for his path-breaking paper on spectral matching techniques in mapping global irrigated area. He also published near about 152 research paper in different his area. Presently, his index is 35 and citation of 5,800. So, may I request Dr. Guma Murli sir for his talk on the monitoring crop plants using remote sensing data and machine learning algorithms for improving the agriculture productivity. Dr. Murli sir, please.
Yeah, hello, good evening all. Yeah, this is Pranay Panjala and I'm giving this presentation on behalf of Dr. Murali Krishna Guma. I am the scientific officer at Geospatial and Big Data Sciences Lab at ICRISAT. Yeah, I want to share my screen. Can anybody give, am I audible? Sorry, am I audible? Can anybody confirm, please?
You're audible. Just speak, sir.
Yeah, thank you. Yeah, this session is about like monitoring croplands using remote sensing data and machine learning algorithms for improving agriculture productivity. First, I go through what are the products we contribute to the agriculture using remote sensing technology. First, coming to that, like if we consider agriculture, the main thing is like crop and also the water. See, in remote sensing, we monitor the croplands or whatever using the remote satellite imagery, as you all know. and with the help of ground data. The major products of our study is like crop type and cropping pattern. Crop type means, like, for example, if you consider certain area, what are the major types of crop types are grown in that area. Like, for example, the major staple crop was rice and wheat. And coming to the cropping pattern, how the crop scenario is changing over the years in that area. And land use changes. As there is major changes in land use, some agriculture lands converting into the commercial lands, and how much is converting, we can compare it with the past years, and we can deal with that. And coming to length of growing periods, see, in order to do research, we need to know what time the crop is sown and what time it getting harvesting, and these help the researchers to continue their research on that. And crop intensity, coming to crop intensity, there are like single crop, double crop, and triple crop. And abiotic stresses, see, there are some stresses like drought stress, flood stress, and or like hailstorm. These all also can be mapped using the remote sensing technology. And water productivity, and how much of yield we can get for how much of like a certain amount of water. And spatial modeling, see, in order to select some area for any interventions, we need to know how much it's prioritization, how much priority should be given to that area. And coming to impact assessment, if you do any interventions, we need to know how much impact had achieved during that time period. And also the yield estimations. Before the like harvesting, we need to estimate the yield based on the like past years, or based on the present scenario, the cropping scenario, like health of the crop. And also tracking adoption of NRM technology, natural resource management technologies. This section is all about how we map using like remote sensing data and machine learning algorithms. First, the basic and the most important thing in order to do like classification, one is satellite imagery and another is ground and secondary data. See, like ground data is very much important in classifying anything. If you read something wrong in ground data, it destroys, like it completely gets biased during the classification. See, like here we have so many technologies are there to classify to do classification. First, from the starting of satellite imagery, what we do is like we download the data. See, it takes a lot of time. With that data we download, it will take 1 or 2 days, or sometimes it will take weeks, based on the like resolution of the data and amount of the data. See, in ICRISAT, we do for total global data, or Africa or South Asia, we will do for like at large extent. It becomes very hectic, like difficult task to download such data and to do analysis. Now, with the help of the machine learning algorithms, like and cloud computing, mainly that Google Earth engine, which helps, we can do process itself in the cloud and we can do analysis there. See, here we have like one traditional technology where we download the data, we do pre-processing and processing using the softwares, and we can do automation in like machine learning algorithms using whole in the cloud computing. And another thing is like semi-automated texts, which is the good technology, which is a good technique. We have to do pre-processing it in the cloud, and we can download the data, and we do like traditional method there, which gives like high accuracy. And based on that, we will make some decision making for that. See, before like first ground data, here in ICRISAT, we like developed one Android application, which is iCrop. This can work even without network. With help of this, we can stand certain like at some distance, and we can take the point with the help of like a location offset, which we have given there. And in this we can take 2 or 3 photos, and we can capture the location like by we can adjust the accuracy correction also, and we can see, sir, for example, if you stand on the road and if your crop like field is at distance of 50 meters, where we can't go because of the standing crop, we can locate the estimate the distance and we can pick the ground data. And we can also collect like land cover type, what type of land cover is it. Like for example, if it's crop type, we can also given the scroll down of different crops and we can save it. See, these are the sample images, and see, it also gives the timestamp and the lat long stamp on the photograph which were taken using the iCrops application, which is very good. And this is the, like, after collecting the data, you can sync that data to the server whenever you come to the network type, and you can sync that data. See, this is the database where and this is freely available. You can get the data on request. See, so far, like in ICRISAT, we have collected the ground data in most of the African countries and also the South Asia. See, there are so much data we have collected, and still we are doing research on such areas using that ground data. See, we basically collect the ground data like our major targets, like what type of crop line. If it is the crop line, it is irrigated or rain-fed. And if it is irrigated, what type of source, like well or drainage or a canal, whatever it is. And also we will take the photographs and what are the soil type. So whatever the information possible, we can collect from the farmers available there. See, you can see the ground data which we have collected throughout the South Asia. And also we have collected some data using like Google it for just to classify cropland or non-crop, because we have temporal images in Google it. See, this is the traditional methodology for classification. First, what we do is we will collect maximum NDVI images for every month. Why we collect the maximum NDVI? Because during the Kharif season, as you all know, there are two types of satellite imagery. One is optical imagery and one is SAR imagery, that is microwave imagery. That optical data is very much vulnerable to the cloud. So in Kharif season, it is difficult to get the cloud-free imagery. In that case, we go for the maximum NDVI images. So we will take one image which has the maximum NDVI for every month. For example, June to October, which is the crop period for the Kharif season in India, especially, we will stack that NDVI images. We will apply the unsupervised classification by taking certain classes. For example, if we take 100 classes and we run unsupervised classification, we will classify that image using different techniques. For example, Dr. Buma is one of the key member in developing the spectral matching techniques, which will help for identification, identify the different classes, especially the crop type, because using that spectral signatures, we can differentiate various crops like rice and cotton and other crops. For example, if you consider the rice crop, in rice crop, during the sowing season, this is transplanted. During that stage, it shows the less NDVI because of water nature. When coming to the peak, peak season, it shows the highest NDVI. And when it is the harvest staging, it shows the less NDVI. So with that, we can classify different type of crop types. See, to classify that, we can also adopt decision tree algorithms, spectral matching techniques with the help of the ground data. As we all know, the ground data is very much important for the classification, and also with the help of the Google Earth imagery. It contains the historical imagery. It shows the past imagery. See, here we have some limitations. In these traditional methods, what are the limitations? The satellite imagery should be downloaded requires high bandwidth data. As I already said, we are working for the larger areas, it requires more data. And pre-processing and processing will be carried out using software. It requires high-end computers. See, in our lab, in our land, the minimum system, minimum configuration we have is with 32 GB RAM. You can understand how much data, how much efficient, how much efficient computer should be required. And it also very has that it takes time. It is very high time consuming.
आता काय तुमचं सगळं हार्वेस्टिंग वगैरेच असेल, सीड प्रोडक्शन काही असेल. तिकडे झालं तुमची व्हायवा?
Sorry. Yeah, see here, see, you can see the spectral signatures here. See how it's varying. Like if you consider the rice or the wheat, which is the first one, during the starting stage, it shows the less NDVI. When it comes to the August, it shows highest NDVI, nearly 0.7. And when it comes to the harvesting stage, it shows again 0.2. See, this is the trend. We have to look that trend using our training data, and we can compare that using nothing but the spectral matching techniques. See, we have classified using the large ground data. What we have classified for entire South Asia. We have classified main crops like rice, soybean, maize, groundnut, pulses, sugarcane, potato, millet, peach and pea, cotton, and sorghum. This is the monsoon crops, and this is the crop type map. You can see how clumsy it is. So that type variation, the crop type in our like India, especially as small holding farms are there, this type of variations is there. But the major crop is like rice followed by wheat, rice followed by rice, rice followed by pulses, and in some areas pulses, millet, wheat, rice. In some areas it is rice followed by fallow, no crop is grown. And this is the spectral distribution, like a spatial distribution of major crops during monsoon season. And this is like winter and summer, like majorly rice, wheat, maize, pulses, chickpea, and groundnut. So you can see like statewide spatial distribution. And also we have done like correlation with the maps, whatever the statistic we got from National Agriculture Statistics, and we correlated. We have achieved like significant correlation. See, also we have did these crop typing mapping in like Africa region. This is the crop type map in of Ethiopia. The major crops over there is like teff, wheat, barley, sorghum, maize. In that area, they almost depends upon, like most of the crop depends upon the millet, the sorghum, millet. Also, we did this type of classification in Myanmar also. And also you can see here, we have did the mapping for monsoon, winter, and summer season also. So we can see how the crop pattern is there and how is the cropping systems maintaining there. And also we have did like statistical analysis where we got good correlation. And next, coming to that, the automation. The most of the these Google Earth engine, where we are doing the machine like classification using machine learning algorithms, what we do is like we call the data from the cloud. I want to tell something about Google Earth engine. The Google Earth in the online platform, where it contains the large amount of satellite data. Whatever the satellite data we got in the respective sites, it comes into the cloud of Google, where we can call the data and we can do analysis over here. In this, we do like what methodology we are doing is like we call the satellite imagery there, and we do processing in that. We do remove the cloud using some cloud free algorithms, and we stack itself there, we run the classification with the help of the ground data which we give from outside. We do classification using random forest algorithms. Many algorithms are there, but random forest algorithm is good with the minimum ground data. See, this is the pictorial representation. You can see at the below, Landsat 8, where we call these type of data. For example, Landsat 8, we have 10 bands. After that, we will do stack for multi-year seasonal composites. Then we make it certain cube, 30 meters data cube, and we do run classification algorithms on that. See, these classification we done itself, overall classification, these irrigated and rainfed croplands we done using Google Earth Engine. Here we got good accuracy, nearly 80% accuracy we got. And also we have uploaded that data in the USGS site where we collaborated on work with USGS NASA. And this is also the methodology. See, in order to take the advantage of the SAR imagery, we did research on to fusion like Sentinel-1 imagery and Sentinel-2 imagery. Sentinel-1 imagery is the microwave imagery which can pass through the cloud, whereas S2 images, that is optical imagery, which is vulnerable to cloud. We took the help of the advantages of whatever the advantage they have. We did by fusion techniques and we did classification. See here, we can see the difference between that, what crop type map using Sentinel-1 only, and here Sentinel-1 and Sentinel-2, where we got like major difference. For example, with the Sentinel-1 data, we got 80% accuracy, where we with the help of fusion techniques, Sentinel-1 and Sentinel-2, we got almost 85 to 90% of accuracy here. And you can see like field level classification, field level changes. You can see, observe here. You can look at that how the sesame and rice spatial distribution, where we got 87.5%. We did this for Chitrakoot and Jhansi, which is in Bundelkhand region of Uttar Pradesh. You can see that. And you can see using different machine learning algorithms. We have like spectral matching techniques, CART, support vector machines, remote sense, random forest algorithms. We have used all these techniques, and we found that also we have to publish this paper. We found that spectral matching techniques gives the good accuracy when compared with the automated machine learning algorithms. And coming to the machine learning algorithms, random forest gives good accuracy compared to the other algorithms. See, you can see the plot level distribution, how it's varying. And also we have one of the major products what we develop is like crop intensity. With the help of the peaks which we look when we are going through the spectral matching techniques, the peaks which you see here, like the red mark, it gives the intensity. See, if you have like 2 or 3 one peak during whole crop year, it shows, it gives it represents only single crop. When you have like 2 or 2 peaks, it gives like double crop. If you have 3 peaks, it represents the triple crop. Using that, we map these crop intensity. If you have like, it depends, depends upon the resolution of the whatever the data we do. The major we are doing is like on Sentinel-2, which is 10 meters data. We also now we are doing it in using PlanetScope data based on the application and the projects we receive. And one of the good paper which we have published is like flood-based farming system. See, in Afar region, which is in Africa, Ethiopia, there the major problem is like there is very much flood in certain in African upper region, where we mapped the flood areas and we recommended that, and we worked with the local authorities. We mapped that area and we showed them this is the certain area and where that flood is occurring, and you can adopt like flood burst crops like rice for the sowing over there. See this how it's changed like 2014 to like 2017, and flood area in each month in that areas like Berg and Meher seasons in 2008. We do these type of products also, so that these gives like information for the local authorities so they can make quick decisions. See, you can see this is the ground data which we have collected when we went to that area. See, you can see how the flood is occurring over there. And this is the like district level statistics you can do like based on the slope and this information we give to the local authorities and what are the authorities there for their decision making. And we found that like going for the traditional methods, it takes a lot of time. Going for the automation, it gives less accuracy. What we do is here, like we take the advantage of both traditional methodology and as well as the automation. See, the most of the pre-processing and processing is done in the cloud computing, and we pick that product and we do the analysis. What are the analysis and what are the classes labeling is done traditionally, because the manual intervention should be there to classify. We don't believe, because sometimes the training data will have the like black sheets which destroys the classification. So we need to find out manually and look at that certain areas. See, within one stretch we can't do the classification. We need to improve that classification by looking at the what are the training data we have. Even with say for example, if it requires 100 points to do classification, without looking that data, if you feed that data into the machine learning algorithms, it gives sometimes the very false classification. So what we do, we need to do for before going for the automation, we need to look at the ground data. See, we need to look at the ground data using like Google Earth Engine. You need to lay that on the Google Earth Engine and look how is that ground data is correct or not. We need to look at that level. Basically, we adopt like a point and a polygon data. See, if you take point data, if it is fall just outside of the field, if we consider that field as the certain field, like if we consider that as the rice field, if the point is outside the field, it gives like wrong classification. So we need to be very careful while doing the ground data, which is very much important. And also it depends upon the classification. If you do classification for the small holding farms, we need to be very careful, because see, there are some like variations. If you have rice in one field, certainly it changes to other crop in another field. Because we have only 10 meters data, it may like get mixed. We need to be very careful in that. See, coming to this, we take the advantages of both machine learning and traditional methods. What we do stacking of images. We do classification of stacked images itself in the machine learning algorithms, and we pick that product out, and with the help of the like training data what we have, we check with that and we do class labeling, which gives like certainly good accuracy compared to the other methods. See here, this is the cropping pattern we did for during the Rabi season as part of one of the projects. Our study areas Jhansi, Chitrakoot and Panna. We are doing like for the last 3 years, and we delivered good products. See, you can see how the variations is wheat, chickpea, mustard, and I can see here you can see the field level, how the variations are there. Plot there is like plot by plot, there are some variations. If you have wheat in one plot, chickpea in another plot. See, if the ground data is wrong, then whole classification will get like false. And this is like we can go for the like field level. See, we have on presently we have like planet data, which is 3 meters data. This is also very good, but it is commercial data where you have to buy, which is very costly. But if you go for the Sentinel-1 and Sentinel-2, which is 10 meter data, which is freely available, by with certain careful within taking some precautions, we can do good classification using this. And also one thing I want to say here, that the governments now they are preparing the shape files, like plot level shape files, and this is one of the best. If we achieve that plot level, it is very good, and we can do like good research when we got these field level shape files. See, for decision making, see, like ICRISAT is majorly worked for like short-term duration crops like chickpea, millets, many crops. We target certain areas where we can get the fallows. See, for the last 20 years, we are doing classification in finding the rice and fallows. So if we give that information, that fallow information to the certain like concerned scientist or researcher, he can target that location. He can target the location. He can assimilate whatever the crops they develop, and they will do research over there. See here, from 2000 to like 2020, we did the rice fallows and how it is changing. And this is the like recent 2019-20. See, you can see how rice fallows, which is majorly in like rain-fed rice fallow, which is in around like Chhattisgarh and Jharkhand. Over that areas, there is very much rice fallow is available. So if we give this information, these become very handy for the researcher or decision makers like governments. If we give this information to them, they can do like interventions, whatever the intervention possible in that. And see, like suitable rice fallow area for legume crops. We also do some climate analysis over there, and why they are not going for the fallow, why they are not going for any crop during the fallow season. We also did some research with the help of the available rainfall data. See, if we have the rainfall data at the AWS level, whatever there, we can do more research. But we have available only like 50 kilometers by 50 kilometers data, which is very much not required, not very much efficient in doing the analysis. Now some governments, they are going for the AWS data, which is very much good, and we can do research over using that data. And we can do that at Tehsil. And sometimes if you get the AWS data, we can go for like Gram Panchayat level. And we tried for the rice fallows for entire Asia using Google Earth Engine, and we have achieved like some good results. And we are also working on that. And watershed interventions, and this is very much important for agriculture development, because the water is the major source for any agriculture. See, with like what are the major inputs for the watershed interventions are, first we need to delimitate the watershed. With the help, we delimitate the watershed using the SRTM 30 meters dam, which I think you already know that. We take the help of that, and also the temporal land use land cover, whatever we achieved through our classification techniques, we integrate these two, and with the help of the weightages or with the help of the like rating criteria, we will select the watershed, in which watershed we can do interventions. So these type of analysis we done it in Ethiopia, which is Abba Gerima watershed in Ethiopia, where see you can see the changes. In 2002, there are very like trees, plantations, shrublands over there. By coming at the end by 2019, the most of the land is converted into the croplands. And see, you can see like with the help of these satellite data or the previous satellite data, we can see the changes from certain year to certain year. And also, yeah, by using these interventions, the agriculture productivity is also increased, and what crop areas was expanded significantly. See, this is the prioritization. How we do prioritization? This is the basic prioritization. What I am explaining here. Now you can go for other methodologies also there. See, what we do is like we take the help of the subject experts. They know. See, as we are the technical spatial side, we don't know much about the soil. We don't know much about the agronomy aspect. We don't know much about the other climate aspects. What we do, we go for them. We approach them. We will ask what type of soil helps what type of certain crops. For example, if we take the rice crop need these type of soil, these type of water facility should be there, these type of temperature should be maintained. We do take help of them. We give the rankings. See, if certain area is getting high temperature and if certain area is getting low temperature, we will rank them accordingly. And with the help of the spatial modeling, we integrate them and we will give the certain product. In that product, you can do like you can come to certain some result giving these type these watershed should be give intervention first, and this watershed whatever the intervention you give, there is you get less productivity. So these information can help the government officials to do interventions in such areas. So this is one of the study where we did prioritization for entire Nigeria. You can see there maximum temperature, minimum temperature, precipitation, slope, soil depth, length of growing period, where we integrated all these with the help of subject experts. We give ranking. Based on that, we prioritize. See, you can see at the right lower one, you can see you can look at that the high priority watersheds, low moderate priority and low priority watersheds. And also for the past 3 years we have been working with the MNCFC, where we are doing Gram Panchayat level yield estimation using remote sensing technology. In that, we adopted technology with the help of the crop modeling. See, the main crop modeling thing, in crop modeling, we get outputs like LAI, yield. So with the help of LAI, which is one of the parameters you can integrate with the remote sensing data, with the help of that, we integrated that data and we developed Gram Panchayat level yield estimation with the help of crop cutting experiments. See, we take the base, which is now again comes that ground data. Ground data is also very important. That in crop cutting experiments, we take that sample, we do optimization of crop cutting experiments with the help of the health of the crop. We classify that health of the crop and we pick. See, for example, in previous years, what the government do is it picks some areas, it collect the CCE, it conducts CCA, and it estimated the yields achieved, and it spreads over the buffer zone whatever they selected. Now, with the help of the remote sensing technology and with the help of NDVI, LAI, and the climate parameters, we optimize that CCE in order to collect the 100 sample over there. With the help of the remote sensing technology, what we do is we pick out same characters of whatever the hell, same character fields we pick, and we will give them the product. You can pick only 50 of them. Out of 100, you can pick 50, which resembles all the fields. And with the help of that, we do DSAT modeling. We adopted DSAT modeling for this study. And whatever the results LAI we get, we integrate that with remote sensing LAI, where we collect LAI from ground, and with the help of the statistical analysis and some like indices. We develop LAI equation, so we can get the spatial spread of the LAI over that region. Then that LAI is compared with the desired LYI, whatever it comes. We integrate with that, and we give the gram panchayat level yield estimation. And also we are giving products to the insurance for deciding their crop premiums. We will we also working with many insurance agencies, and we give cropping pattern maps, length of growing periods, like crop stress map. We give a crop stress map for every fortnightly, for every 15 days, and so that they can decide like which area they have to target, how to decide the premiums. For example, if that area is very much vulnerable for crop stress, they may increase the crop stress crop premiums in that area. So their calculations are different based on that, but we give the crop stresses map. And we do yield predictions, climate analysis, and crop-based advisories, which we work with one of our department. And we do like capacitating farmer collectives for risk mitigation and resilient communities, and developing meso level insurance products, policy advocacy. And this is one of the good projects we worked on the help of STC. See, where we like compared the remote sensing LAI with the DSAT LAI, and we achieved 70 to 75% of correlation for certain areas. This is a good accuracy because the variations in the spatial distribution, this is a good accuracy. See, this is the spatial spread of yield estimation for especially for the groundnut. And also we did one of the study crop water productivity in a Kadam command area in the Adilabad and Karimnagar region in Telangana, where we started from the basic scenario, like baseline scenario of LULC classification, then cropland classification, then crop type classification. And we calculated the what are the water irrigation they are allowed, and how much water it is using, and the productivity is good or not. And we studied entire study, and we submitted, and we got good appreciations on this. See, even though we do analysis at level, there are some gaps and limitations in using remote sensing data and machine learning algorithms. As I earlier said, coming to the satellite data, the optical data is vulnerable cloud cover, especially during monsoon season. So it is very difficult to classify in that areas. So here image classification is, but you can add up SAR images, but it is not as good as the optical data because of high noise in the SAR data. As SAR data is the backscatter data, and also some another limitation is the much dependence on indices. See, the indices also differ based on the local agroecological conditions. So you need to very much careful, because by giving the certain thresholds, we can't do classification. As I earlier said, 0.7. If achieve if there is 0.7, it is not rise. Sometimes it is rise. We need to verify that. So we can't do any standard algorithms while classifying the image. Coming to the Google Earth engine, which is for machine for do automatic classification in Google Earth engine. So we can't standardize the automatic algorithm for classification. See, if you apply some cross classification techniques in certain area, it may not apply in other areas. And there are some limitations crop type classification techniques. We need to improve that, and object-based image analysis. See, if you work on the large types, there is some problem classification computation time run out. See, we need to improve our code. see there is some also code. The code is basically we adopt Java and Python. Sometimes based on the code also it will get differed. Majorly it differ because see like if you adopt arrays or list function, it will take huge time for to run the data. So you need to avoid that functions, and we need to do the direct functions or predefined functions for the classification. See, many factors will affect that, so you need to very careful on that. And it is not possible to do like map composition layout in Google Earth Engine, or there is only we can format, we get format in T format. There is no for .img format we can't get. And also filtering and smoothing of the data. Even though we have many algorithms to filter or smooth the data, but still it needs very much improvement. And also if you downscale certain, if soil moisture data sets or climate data sets, there some like gaps are there. Then you need to refine that also. And we have major publications like automated cropland mapping, or and also like in Australia, China, and as earlier said, like assessing potential locations for the flood-based farming, and many other things we are in and we are doing, and we are improving ourselves. And we are also now looking at the deep learning algorithms, and we are improving ourselves. Like if you have any questions, you can ask, or I can explain you.
Thank you very much. Thank you very much, Mr. Pranay Banjala. On the behalf of Dr. Bhuma Murliji, you have presented very nice and give the whole information regarding this topic. So before ending this session, let me extend my deepest gratitude to all the speakers and reporters from this afternoon session. So I'm very much thankful to speaker Dr. Rajendraji and reporter Dr. P.H. Vaidya from section 4. I'm also thankful to Dr. Parag Sutarji and Dr. B.S. Agarkar sir for the 6th session. I'm also thankful to Dr. Umar Murli and Dr. P.S. Kapse sir for chairing this last session, that is 7th. I'm also thankful to all scientists and associated members from the NAHEP, and very much thankful to all participants who have joined offline or online mode. So thank you very much, one and all. So tomorrow we will gather at exact 9:45 for tomorrow's session, and the mandatory function will be at the 4 o'clock. Thank you very much.
Hello, Pranay, am I audible to you?
Yes.
Hello.
Yeah. You're audible.
On behalf of Dr. Murli, you have delivered nice presentation, I know. And due to some urgent call, sir is not in Hyderabad, so he is in Delhi. And we hope we will in future collaboration for with our university and its institute On behalf of our Nahib project and our organization, I express my sincere thanks for delivering such a nice talk to our PG students and faculty members. Thank you very much. Thank you.
Yeah, thank you for giving our opportunity to give the presentation, and we very much eager do collaborations with universities so we can develop.
So for tomorrow, we are gathering after the morning breakfast. We are gathering here around 9:40. So our first lecture will start exactly at 9:45. So tomorrow we have another guest lecture from University of Florida, Dr. Vivek Sharma. He is going to present. So kindly bear with the time because we have the time difference around 10 to 11 hours. So there, when we are starting in morning, they have the nights. So around after 10 they are sitting. So we need to finish their talk. We need to utilize that time. We have to discuss again. We don't want to listen because speaker is expecting some questions from participants. So try to think in such a fashion what the talk is going on and what are the questions for my own field in agriculture sector. How can we utilize that, particularly application part? So question part will be there. So second lecture, I think we have from the another expert, Dr. Dave. He is from IIT Kharagpur. So he is coming today evening. So he will give the lecture. Then next one is subsequently we have another expert from the IIT Kharagpur, Professor Dr. Bhattacharya. So he is giving lecture on the census applications. So that lecture is also very nice. And after lunch break, most probably one of scientists from the Erie, Philippines, he might be not able to come, but he will give the lecture online. And last lecture we have from Dr. Bhimal Kumar Bhattacharya from Space Application Center, Group Director. Unfortunately, he was not visited our campus in yesterday program. He was the chief guest. So he will be delivering lecture, and subsequently we have the valedictory function. So in valedictory function, we have two guests of honors. So one is physically present here, one is just from the virtual mode, he is remain present. So in valedictory function, we are distributing the certificates. We will try to distribute certificates. Then we will have the discussion among what are the outcomes within these 3 days. So we will discuss that deliberations also. And at the end, after listening the presidential address, at the end we have a very good, beautiful photographs here and outside our hall. So in between, I will try to find out some time. Gopal Sundar sir has today given one online. I think he has you all are visited to Naib Center. So we will try to visit tomorrow also. We will find out the time and we will visit once again. I will try. Sir, we need to be here before 4 o'clock tomorrow again. So we will find out how our speakers responding. On that basis, we will come here. Okay. So for today, session is over, and we will gather sharply at 9:40. Before 9:40, I am expecting, because if you are coming late, again that another person sitting abroad, he will having the trouble. Okay. So kindly be here for tomorrow also in same fashion, and we need the presence. So till tomorrow, thank you very much. Bye bye. Good evening. Thank you.